I feel privileged to extend my warm welcome to all of you for this interactive workshop on marine discharge. Mission Life is India-led global mass movement with an aim to nudge individuals and communities for pro-environment lifestyle. The objective is to mobilize at least 1 billion Indians and global citizens to become pro-planet by their individual and collective community action for protecting the environment. AP Pollution Control Board prepared a national plan for implementation of Mission Life program and undertaking series of events and activities like rallies, beach cleanup, competitions to sensitize the individuals and the community for protecting the environment. This workshop is conducted as part of the Mission Life program. In today's workshop, we have two sessions. One quick inauguration session followed by the technical session. Now, I invite dignitaries on the dais. I invite respected Sri Nirkumar Prasad Garu, IAS, Special Chief Secretary, Environment, Forest, Science and Technology, Government of Andhra Pradesh. Sir, please come on the dais, sir. Thank you very much, sir, for your gracious presence and consent to be the chief guest for this workshop, sir. I invite Sri B. Sridhar Garu, IAS, Member Secretary, AP Pollution Control Board, onto the dais. Thank you very much, sir, for gracing this occasion. Sir, under your leadership, we are implementing Mission Life Action Plan successfully. Recently, we conducted a mega beach cleaning up event successfully with 3,000 volunteers joined there. And almost all the industries and hotels, hospitals, volunteers have come from. Also, we are that individual pledge as well as collective event. We are now counting numbers, sir. That is progressing very well, sir. Now I invite Srimati Varalakshmi Garu, Regional Director, Central Pollution Control Board, onto dais. Thank you, madam. Actually, I know that you have another schedule, but you have changed the schedule and joined here. Thank you very much, ma'am. Today we have many experts who will share their expertise and throw insight on various topics of marine discharge. I invite the panel speakers also onto the dais. Sri T.N. Srinivas Garu from National Institute of Oceanography. Okay. Sri Patra Sivaji Garu from National Center for Coastal Research. Dr. Manik Mahapatra Garu from National Center for Sustainable Coastal Management. Please come on to the sir. Sri Bhaskar Garu, expert on desalination plant design. Come on to this side, sir. Okay, fine. I request Narayan Raj Garu, Executive Director, Deccan Fine. And also Sri Sridhar Garu, EHS head from DRL. I invite Sri K. Sriramurthy Garu, Joint Chief Environmental Engineer, Pollution Control Board. Please. Murthy, no? Now I request the respected Member Secretary APPCP to preside and kindly give inaugural address.
Good morning to all of you. Respected Chief Guest of today's workshop, our Special Chief Secretary, Environment, Forest, Science and Technology, Sri Nirkumar Prasad Garu, and other dignitaries on the dais, and representative from various industries, institutions. A warm welcome to all of you for this today's workshop. The present workshop is organized in the event of ongoing India G20 presidency under the concept of Jana Bhagidari for a collective role in implementing policies. The Ministry of Environment, Forest, Climate Change, Government of India, as a leading environment and sustainability working group, came out with the concept of discussion on prevention and management of marine litter. So accordingly, today we have invited all the industries who are having this marine outfall into the sea, and also other industries in the coastal area for this workshop. So the United Nations reported that only 60% of surface water bodies assessed in 89 countries for the Sustainable Development Goal has good quality status. Many of these countries have made substantial capital investment to upgrade wastewater treatment and reduce effluent disposal to rivers, lakes, and coastal waters. International best practice guidance on management of wastewater treatment and disposal identifies options to improve treatment and effluent quality, reduce the effects of the discharges on the environment and human health. When identifying locally appropriate management options, discharge consenting authorities consider many factors such as technological and engineering constraints, the characteristics of the effluent, the hydrographical and hydrological characteristics of the receiving environment, and its environmental protection, and community values also social, cultural, and spiritual, and the potential and actual effects of the discharges. So as you know, wastewater comes from a variety of sources: households, commercial, industrial facilities, hospitals, offices, etc., and contains a variety of organic and inorganic constituents. Those of greater ecological and human health concern are suspended solids, organics that affect biochemical oxygen demand and chemical oxygen demand, nutrients, pathogens, metals, emerging organic contaminants, oil and greases, etc. So it is the need of the hour to protect our water bodies and marine water quality. Our oceans cannot be considered as an infinite sink capable of assimilating millions of tons of waste generated. As you know, marine water quality also influences the ability of the fish, crabs, and other marine animals to grow and reproduce. Marine water quality is also affected due to microplastics that are an emerging threat contributed from various industrial sources. Microplastics are concerning since they do not naturally break down in the environment, reduce marine water quality, and harmful to marine species. So Andhra Pradesh in India, it is having the coastal line of about 974 kilometers length, which is next to Gujarat. And the coast has been endowed with important rivers, lagoons, major and minor ports, fishing harbors, monuments of international heritage, tourist locations, and pilgrimage centers. So the northern coast of Andhra Pradesh emerged as a boon to a good number of industries in various sectors that came up in the coastal districts of Visakhapatnam, Anakapalli, and other Nellore and other districts, basically for discharging their effluents through marine outfall. Marine outfall system facilitates discharge of treated effluents into the sea, allowing rapid mixing of effluents and emission several times, thereby reducing the toxic effect on marine environment. The marine outfall system reduces the cost of effluent and energy efficient. APPCB permitted marine discharge for 3 CETPs, 6 bulk drug manufacturing industries, and 1 agrochemical industry in the jurisdiction of the Zonal Office of Visakhapatnam. All the industries were accorded clearance by MOEF through EC and have established the facility for a marine outfall as per the design and approvals provided by the NIO, National Institute of Oceanography. APPCB designed a standard operating protocol for monitoring of the industrial discharge through marine outfall. All the marine discharging industries installed online analyzers for monitoring the compliance parameters for allowing discharge by the regulator as per the SOP. APPCB is reviewing the industrial activities from time to time to upgrade the marine outfall system with the latest technologies available towards protecting the marine environment. So I hope today's workshop shall lay a platform for all the stakeholders, policymakers and regulators to emphasize on the challenges faced in the marine outfall system. The workshop shall create awareness on the latest sophisticated technologies available globally for improved treatment systems that offer economical solution to wastewater disposal and have minimal environmental impacts. So I expect a very useful workshop today. Speakers are there from different institutions and from the industry. They will throw light on the technologies available and how to discharge these effluents into the sea and protect our environment. Once again, I thank the Zonal Office for conducting this workshop in a short period. And I also thank all of you for coming over here. Though our time is, we have given very less time for you to attend this workshop. Once again, thank you one and all. Thank you.
Of this interactive workshop on marine discharge. I welcome all of you for this meeting, and let me begin by saying this is going to be an interactive workshop. This is the last point that we will be here. We will all be that side, and there will be only one person making the presentation. And after the presentation, we will be having, at least I will request all the people who are speaking to speak and leave at least few minutes for the interaction after their presentation. So that is the structuring of the whole thing. In this session, we will begin with outlining the details of the marine discharge standards as prescribed by the CPCB, which will be presented by Varalakshmi Garu. And after that, as you are aware, we had prescribed one standard operating procedure for the marine discharges from the AP Pollution Control Board. So we will have a CPCB presentation on the marine discharges. We will also have a presentation on the standard operating procedure of a marine discharge by the Andhra Pradesh Pollution Control Board. So that will be the first group of sessions. Then we will go on to some issues which come in the marine discharge. We will begin with a presentation by Dr. Reddy Labs, in which, we have an advantage of coastal state and we have a competitive advantage. Definitely, we will carry on with our competitive advantage of allowing marine discharges, but within the prescribed standards. So that point, let us say, is not in dispute. But at the same time, we want a presentation from the Dr. Reddy Labs to make a presentation because this is one unit which has gone for a zero liquid discharge after having the marine discharge approvals for some years. So we just want to understand what they have done to have a zero liquid discharge. This we will follow up with another presentation from the Deccan Fine Chemicals. I'm sure all of you are doing it, but Deccan Fine Chemicals agreed for a presentation. So we will have a detailed presentation on segregation of the waste, liquid waste, streams, treatment, methodologies, followed for the safe disposal on the marine discharge. We will have a presentation with Mr. Raju from Deccan Fine Chemicals. Then we will have presentations of the marine discharge. Our member secretary mentioned about the sea conditions. You leave it at 2 kilometers, 2.5 kilometers, 3 kilometers, whatever distance, 1.5 kilometers. So what is the effect of these marine discharges in the ocean? Now we already have a NIO Visakhapatnam conducting state of the ocean reports for these studies, and we are increasingly trying to work with the Department of Earth Sciences and the NIOS and other agencies involved in this as to keep on giving us feedback on the system of that after the marine discharge, how is the water condition in those areas. So NCCR has started one, they have put some buoy for a continuous monitoring. Right now it is not at the marine discharge point, it is more in the ocean, in the sea for getting the water quality, that is for the beach water quality of Visakhapatnam. But we are in talk with them, we are trying to enter into an MOU with them that please also give us the water quality report at each of these marine discharge points. So this is one side, you are having a marine discharge monitoring and discharges. The other side, we want to see the effect on the environment also. So we wanted to have these things on as assessment. Lastly, we will have two new issues or two issues which we want to focus on. One is the desalination plants have coming up large scale with industries, with this. As you know, the desalination, you take up the seawater, you take out the good quality water, and then you let out the high salt content brine water into the sea again. Now that also has a marine discharge standard. You are letting it out on the sea, it does not have a chemical, so to say, but at least you are letting it off in the sea. So we want to understand the desalination plant issues also, and many of you industries are going on the desalination plant route. So we need to understand and we need to set up a system. And lastly, when you apply, apart from Andhra Pradesh Pollution Control Board, we also go for the CRZ clearances, you also go for the environmental clearances. So we have a specific session, last session, on the interaction of the marine discharges in terms of the CRZ norms. Means, of course, there is a pipeline which crosses the CRZ zone on land, and then it goes into the sea, which is in the CRZ 4 area, and what is the effects on the, how does the CRZ regulations impact in the marine discharges. So these are the sessions we have proposed. Again, I emphasize it is interactive workshop, and why I'll tell you. If you remember, I had the privilege to have one, I think, interactive workshop with you in 2019 when we had a detailed workshop, and I think that was organized in Vijayawada, if I am not correct, if I'm not mistaken. It was organized in Vijayawada at that time, and we had a detailed discussions, after which we came out with the standard operating procedures of the APPCB of the thing. I would say this is take 2. We want to now go to the reforms 2. We want to go to the next stage of refinement of the marine discharge standards. As I already told you, there is a competitive advantage. We don't want to say that no marine discharges. No, we don't want to say that. But we want to definitely say we are all very ecologically aware. We are all very environmentally sensitive, and we take care of the environment in the best possible manner, in the best technical standards. And this is where I value and request you to give your inputs to the maximum extent so that whatever the next step we take for our, I would say, marine discharge SOP 2, we should have your inputs and we should see that these systems are fully streamlined and we work in a manner which is environmentally sensitive. We take care of the environment and we take care of our growth, employment, and all other issues. So, with these words, I welcome you all for this interactive workshop. And I just want to say a word about the mission life, which is what we are going to do. As you are aware, you would have read in the newspapers or heard about it. The mission life is a concept life for environment type thing, and the Honorable Prime Minister has taken it as a global mission, and this has been accepted by our state government to take it up in a large scale among all the units, all individuals, all industrial units, every way it will be made into a lifestyle change which will bring in an environment. So we will follow up with a pledge, and then we will on the mission life, and then we will begin with the technical sessions. Thank you very much.
Thank you very much, sir. You have outlined the structure of the workshop, as well brought to the notice of the participants about the balance between the discharge regulation and next level of monitoring. Thank you very much, sir. Thank you very much. And with this inaugural session is over, I request the dignitaries on the dais to take the front row.
Color mic is there. And no, this is okay. Okay, shall I continue, sir? Okay. Good morning to all of you. So just I'm giving a outline of my presentation. My presentation comprises of that overview on a deep sea discharge and classification of seawater quality. First, before going to the discharge, we should know what is the classification existing. And then under Schedule 6, we have a one general standard discharge. And under Schedule 1, we have a standards for discharge of treated effluent into sea for CTPs. And then we, apart from that, we have some industry-specific standards also. Okay. So I think it's not a new things. You all knows. So marine discharge means it's like a designed outfall. Designed outfall considering to the factor like a current, tidal effect, and dilutions, available dilution. So this is called the deep marine discharge. So if you see the scenery of the India, so this system is practiced in the mainly in the Gujarat. In Gujarat, many places they have practiced, and in Tamil Nadu only in two places. One is Kadalur and another is Manali. In Andhra, Visakhapatnam. So as like a surface, I think so you all may be knowing that the classification of our surface water quality depending on the activities, best designated use. In the similarly, we have even for seawater also. So seawater is classified into 5 types. So it is depending on the activities involved. If any activities are like salt pans, if suppose that water is drawn for a salt pan, same, sir. Sir. So in individual, this one I am giving, sir. This is the just, okay. So if suppose, if any activities involved, like that water is drawn for like a salt pan or self-fishing or marine culture, so that quality should be meet this criteria. So here we given only pH, dissolved oxygen, color and odor, floating matter, suspended solid, oil and grease, and only few heavy metals, so which are means critically to the marine life. So next, if suppose the second is SW2 is that like water, that activity involved bathing or any contact water sports. If that type of activities are there, then that water quality should be maintained this way. So here, that earlier if you see in the dissolved oxygen was a 5, but at any cost it should not be less than 3.5. Okay, so but here we put a dissolved oxygen, that requirement is a 4. Okay, and here that at any cost it should not be less than 3.5. So apart from that, here we specified fecal coliforms because it's a come into contact of the human skins. So that's what fecal coliform is a very important. So that standards we introduce. And then BOD. BOD should be always less than 3 milligram per liter. So in class 3, so class 3 is like a, for if any industry is drawing a that seawater for once through cooling, or even for recreation activity is there, then that standards, that means that quality should be maintained, should be meet these standards. So here apart from that, dissolved iron and dissolved manganese is very important. And then for class 4, it's like for harbor activity. If any harbor activities is there, so it should be the standard, so that quality should be meet the standards. So here only fecal coliforms instead of earlier 100 per 100 ml, here 500 per 100 ml. This is the change between the second and this class 4. And apart from here, biochemical BOD is a 5 milligram per liter. So in class 5, this is for navigation purpose. For navigation purpose, this is the water quality should be maintained. So next, under Schedule 1, I think so you all may be knowing CPCB developed industry-specific standards for more than 115 industries. So wherever industry-specific standards are not there, it is necessary to meet these standards. So that's what we call it as under general standards. So it is notified under Schedule 6. So here if you see that for inland surface water and marine coastal almost similar, only few parameters are relaxed. So for example, So here if you see, even that oil and grease, for inland surface it's at 10, but in case of marine disposal it's a little bit relaxed to 20 milligram per liter. So similarly, even BOD also. BOD for inland surface it's only 30, but in case of marine it will be like 100. So here in general standards, one more thing we have to notice, this is 250, COD is at 250, but in case of COD, little bit relax is there. Okay. And similarly, mercury also, in case of inland surface, it's only 0.01, lead is 0.1, but in case of marine, it will become a 2. So that hexavalent chromium, in case of inland surface, it's a 0.1, but in case of marine discharge, it will become a 1, means almost 10 times relaxed. And in case of zinc also, it will become a 15, and nickel 5. But other almost all parameters, it's like a similar to our surface water discharge, whatever standards we have, same. Okay, around 39 parameters we clearly given. So what are the standards should be meet if any industry is preferring to discharge into the marine. So apart from that, we have a CETP discharge standards also. In 2016, MOF notified and prescribed that it should be carried through well-defined and designed marine outfall only. And then we asked to stop shore discharge. 2016 onwards, it is not allowed shore discharge. So, and also that another condition, so that in such a way you have to design that your marine outfall at the point of discharge, at least 500 times of dilution should be available. Okay, and in the from the point of the discharge, 100 meter away from the point of the discharge, so 1500 times of dilution should be available. This is the condition given by the CPCB. So here also if you see, for this is especially for common effluent treatment plants, so almost same, almost similar to inland surface water, but only thing is like as like earlier, it's a BOD, instead of 30 it will be 100. And in case of nitrate, nitrogen also in place of 10, it is become a 50. But here phosphate is not specified. And one more thing, TDS standards, that's not specified. So zinc similarly here also, instead of 5, 15, they have up to 15 it is allowed. So but other all heavy metals, whatever given to that surface water discharge standards, similarly here also we have to meet these standards only, there is no change. So that's what the condition given, that earlier I have told, what should be the available at the point of discharge and 100 meter away from the this one. And here one more thing, that SPCB can relax that, but in the standard we given 250, but up to 500 it is allowed, with a condition that availability of the dilutions. Okay. So apart from that, in the CETP, one more condition we given. Suppose, so CETP pertains to only group of a cluster of a textile industry, then it is mandatory to meet the industry specific standards. Then you have to refer industry specific standards. So for this category we given textile, electroplating, tanneries, dye and dye intermediate, organic industry chemicals, pharmaceutical. These cluster of industries having any CETP, if they propose to discharge, then it is a mandatory to meet the industry specific standards with respect to these parameters. So apart from that, we have a 7 other industry specific standards for marine disposal also. Like we have man-made fibers. So for that only few parameters we described, like a pH, suspended solid, biochemical oxygen, BOD, zinc. Okay, and other one is dye and dye intermediates. Separately we have industry specific standards for marine disposal. So even if they common disposal, then it is required to meet the standards. Dye and dye intermediates, same, it's continuing with that one only. and tanneries also, and then all integrated textile units. So for them also we given a marine disposal standards here for given all type of this one. So that's what here it implies to marine disposal also. And then electroplating and anodizing industry, we have a separate standard for marine discharge, and electroplating, anodizing, organic chemical manufacturing industry, pharmaceutical. From 7 industry specific standards for marine disposal. So out of one more thing, I would like to share one more success story in the Tamil Nadu. You please run that one, Q6. So in Tamil Nadu, in Kadalur, one Sipcot area is there. There almost all industries are chemical, either chemical or pharmaceutical, and a few textile industries are there. So earlier, TNPCB given a permission for individual industry marine outfall. So it was they found it was very difficult to monitoring. So then they asked the industry to stop it. So then what they did, so they formed one Q6 system. That Q6 means like a Kadalur Sipcot Industries Treated Effluent Collection Marine Disposal Schemes. So they formed, and here that, as I said, that in the Kadalur, that major industries are chemical industries, pharmaceutical, and a few textile industries. So they designed a marine outfall system. It's not moving. So for this system, around 18 industries are the members of these systems. So total flow for design is 300 meter cube per hour. Okay. And they have a separate sump capacity also. Here, actually, this is like a Sipcot area. Okay. So here, whoever the member, so they are collecting the effluent from each members and having 2 intermediate sumps. And then near to that, depending on the pipeline network, so wherever change of levels or elevations are there, they have a intermediate sumps. Then from their intermediate sump, they will form to another one common, which is near to the disposal. They have a one common sump. Okay. So then that all effluent go to the common sump only. Then from that common sump, they are discharging into deep discharge, deep marine outfall, through deep marine outfall. Here, 3 level of monitoring system is there. So one is that individual member industries, they supposed to ensure that the discharge standards, whether their treated effluent is meeting the discharge standards or not. So they supposed to submit a report to the TNPCB and the Q6. And Q6 also, this system, they also every day they are collecting the sample and they are monitoring. And then again, that even the common that common collection tank also, from there also they are taking and monitoring. For all the systems are connected with the online real-time monitoring system and connected to TNPCB. So this is the design of that outfall. So it is like from offshore to that deep sea, it's around 1 kilometer, around 0.97 meters, 0.97 kilometers. So here that actually this system was started in the year 2005, it seems. Since 2005, so absolutely there is no problem, sorry. There is no problem. It's working completely with a full capacity and no public complaints received because of a 3 level of monitoring system exists in the system. So this is the photograph taken when they have erected the marine outfall. So this is like this, and then every week they are monitoring even at the point of discharge. Every week, even that QSEX is monitoring and they are submitting the, and then TNPCB is monitoring every monthly once they are monitoring at the outfall. But every day they are taking the sum, means all our real time means analyzers are connected to TNPCB. So every day they are having the all the data. So that's what, without any problem, this system is working since from 2005. So this is the that pipeline dias and sump details. Okay, thank you.
If anybody has any question, a mic will be circulated. You can raise questions. Yeah. Venkat, mic. Mic ఇవ్వండి అక్కడ. Before going to the
I can understand. And discharge unit, what you have proposed, Kadalur part, actually the same, this discharge pipeline, actually I have witnessed in Andhra Pradesh, there is an ONGC effluent plant, I think nearby Amlapuram and ONGC line, where a similar effluent plant was constructed so that that can be discharged into the deep sea. The same photographs, the same methodology they have implemented, and I think Anna University or IIT Madras has given the approval for that. But later, after 1.5 years after the pipeline was installed, I have went there, and that was a failure actually. The reason was, I have seen in the photograph, the pipeline, what was the diameter of that pipeline, ma'am? Okay, no problem. The diameter of the pipeline, okay, the discharge unit where you are filling the diffuser. Okay, you have that counterweights attached, that is the blocks, but the thing is, they have on the design, they have concentrated on the gravity part. That is, these blocks have been kept whenever there is air in the tube or something, that will not come to the surface. But the part that was missing was the currents. The underwater currents when they are moving in the shore area. So in that plan, what they have proposed from Anna University,
how that if it is, then since 2005 to till date, there is no
Okay.
problem at all.
Okay.
Okay, so similar, I'm not asking similar things, but a design part, you have to always look into the tidal
Okay,
current.
those effects at those
Yes,
locations.
you have to consider these two.
And also,
then
ma'am, one
based
more
on
thing.
that, you have to design.
Yes, ma'am. And also like marine discharge standards, I think you are and when you are leaving these discharges into the sea, is that temperature also monitored of that specific thing?
Yes, actually.
temperature
that
of the
it should not
discharge.
be- Yes, it should not be more than the 5 degree.
5 degrees.
Yes.
For that,
That also very important.
okay.
For aquatic life.
There.
Yes.
I understood, sir. I understood. No, is it meeting or not? Because many
Yes,
places we have seen
it
that
has to be, no.
the
It
plankton
has
is
to
not been developed in those locations
No,
and
it
all.
is only in case of that wherever they're drawing the water for cooling, once through cooling, there some problems we faced. So it's very
That is for
difficult to
intake,
meet,
for
yes.
power plants, what you're
Power
telling.
pla-
Intake
then
wells.
Again, once through means again they're taking and they're sending back to the sea only.
Okay.
So while discharging, it is a mandatory to meet that 5 degrees only.
Okay. I
But
think
in
in
some of the cases, they are failed to meet. Yes.
yes, yes.
Yes.
Tirkadiyur, I think there is one plant, PPN ports. I think they are taking the intake, na? Intake and
yes,
discharge, the similar procedure.
Even in Tamil Nadu, Manali, that NTPC and all, they are taking
Yes,
for
sir,
one
intake.
through. Yes.
Correct. Sir. Okay. Thank you.
Okay. Any other?
This is Dr. Naidu, former senior principal scientist, NAO RC Mumbai. Actually, this in your presentation, WAPI out dumping into the Damanganga, even that is exposed during low tide.
No,
I have
what
suggested
told, these
I have suggested new outfall in the coastal area, but they have not gone. Now they have come to the NIO, and now that project is on. So they are going to the offshore. Actually, the case went to the NGT also. I represented in NGT for
Sorry, that's-
NIO. So there is no outfall as such.
I would request, let us focus on our things, not to bother
yes,
about
yes,
other
yes.
states right now.
And
Okay.
so another.
I'll request
now
all of
the
you
NAO
to
is doing
focus
that.
on our issues and
Yes, yes,
not
yes,
to
yes.
go to
Yes,
other
yes,
states
yes.
right now.
Yes, yes,
And let us just keep on the focus on the subject.
Okay.
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 So
Thank you.
let WAPI do something,
another
let Gujarat
thing,
do something.
this,
I'm not bothered right now. Let us talk about Andhra Pradesh and things. CB regional office Chennai, if you ask her about Gujarat or something, she will not be able to answer. Okay. Okay, and then
okay.
it's not a question. Please
No,
talk
no,
on the marine discharge standards.
No, no.
If you have any question.
Because WAPI is mentioned in the presentation, so I am asking. They
No,
just
that
have
is
mentioned.
in scenario I told. The where we are means practicing this marine discharge.
Yes, marine
so
discharge.
WAPI also one of the place. Okay.
Another thing, this just now we have mentioned this one that more than 5 degrees above ambient temperature. That means
should
5
not be
degrees.
high.
5 degrees above ambient temperature. If it is once through cooling system, I think that is not possible. Maintaining 5 degrees this one. Because in MOF guidelines it is mentioned 7 degrees.
No, sir. 5
But
degree.
another
5
system
degree
is there,
only.
5 degrees. Yes, I agree.
5 degree
Another
only, but now they have to make the way that has to bring to the 5 degree only, sir.
Yes.
So there is no relax on that.
Actually, there are
temperature.
two systems. One is once through direct cooling and once through cooling. Once through cooling, I think say 70, the 5 degrees is not possible. what I
Then
come to know.
then you have to give a representation to MOF only. So, but till now we have not so far received any representation from any
Okay, but
states. Okay.
actually I was a member EAC.
Uh-huh.
I suggest mostly 90% we suggest that only. You should not
Only till now we
go
received a
beyond 5 degrees
representation to
5
relax
degrees centigrade
CO2.
above ambient. Yes, we suggest that. Okay.
What the point I think Dr. Naidu you're making is that 5 degrees centigrade may be a difficult thing to adopt by many industries who are letting it out directly, isn't it?
Yes. But
But anyway,
usually,
that's the norm.
as a pollution control board, we suggest 5 degrees only. But sometimes it may not be possible. It
Only
goes
sometimes,
beyond the 5
sometimes,
degrees.
but then that what sometimes you have to find out. You have to find out, and then we have to find out the solutions.
Actually,
Not all the
in
time.
old this one, in MOF 7 degrees only.
And 2016 is the guideline
Yes,
which you
yes,
have
yes, sir,
issued.
yes, sir.
I have a question in that.
Yes,
If
sir.
can you have also said that because we are having a marine discharge conference, I didn't want to divert, but you have also said there is a discharge standard for irrigation, which is on land. There is also a discharge standard for in a inland body, water body.
Yes, sir.
Now Supreme Court has given some directions on that, isn't it? So how does your norm vis-a-vis the Supreme Court, what is the status? Is it in consonance with the Supreme Court guidelines?
Sir, actually now the standards are there, but frankly speaking, we are not allowing any industry to discharge an online.
So that's
means,
what I wanted
surface
clarity
water. But
from you.
still, yes.
Because you had
Yes.
made this thing.
No.
So
No, but standards are existing, but it's up to the, because that carrying capacity of that river or that problem. Local, this one, then the SPCB is having
basically now, in
yes.
view of the Supreme Court guidelines, you are not operating that part of the
Yes, sir.
standards
Yes,
is what
sir.
you are
Yes, sir.
saying, right?
Yes, sir.
Just I wanted a clarity on that.
Yes, sir.
So that let there not be a confusion.
Only, yes, only in case of sugar industries, we are allowing for online, means irrigation purpose. Yes. Not on the online, unland discharge. And in the name of irrigation, we are allowing only for sugar industries.
Only for sugar.
Yes.
We have for many other industries.
Ha, ha. Ha, ha. Okay, thank you.
I too have one presentation about the SOP being followed by APPCB in monitoring the marine discharges. Marine outfall system. Marine outfall system facilitates the discharge of treated effluents into sea, allowing rapid mixing of effluents and dilution by several times, thereby reducing the toxic effect on marine environment. The marine outfall system reduces the cost of effluent treatment and energy efficient. The most key issue is how to regulate key issue is to bring balance. That means monitoring without any toxic effect. At the same time, facilitating the discharge by the industries as it is a more viable than any other disposal system. That's the reason most of the industries opted to come to this north coastal area. We have permitted discharges of 10 marine outfalls in this north coastal districts. Andhra Organics, Aurobindo Pharma. Yes, sir. Sir. No, go to the previous slide. The regulatory body, any marine outfall has to take 3 clearances. One is Minister of Environment clearance. Second is CRZ clearance. Third is CT/CTO of AP Pollution Control Board, in this case for North Coastal. Marine outfalls were established as per design. Yeah, okay. Marine outfalls were established as per design approvals provided by the National Institute of Oceanography. They take the dilution factor, how to reach fast the baseline concentrations. That is the key issue. We have permitted 3 CETPs, Ramki, AHL, and 6 number of pharmaceutical units, 1 number of agrochemical unit in the jurisdiction of Zonal Office Visakhapatnam for discharge of treated effluent through marine outfall. More are expected to join in this group. Go to the second one. These are the 10 marine outfalls. Yes, sir. Sir, Andhra Organics Limited, Arabinda Pharma, Lantec Pharmaceuticals, SMS Pharmaceuticals, Divis Laboratories, Ramki Pharmacity CETP, Anakapalli, Brandix Apparel City, Anakapalli, Astapuram Effluent Treatment Plant Limited, Anakapalli, Deccan Fine Chemicals Private Limited, Anakapalli, Heterodrugs and Labs, Anakapalli. These are the 10 marine outfalls. Go to the next one. Approvals given to the above 10 units after marine EA studies, outfall point is decided based on the dilution and dispersion factors. While facilitating the treated effluent discharge, quantity and quality of effluent is regulated. Discharge standards of CPCB are followed in this case while stipulating and issuing the consent order. Go to the next one. Earlier, we used to, they are let out by the industries after treatment of the effluent. But since 2019, we have a SOP where the effluent is controlled and permitted to discharge in the presence of officials. Physically, the officer is present while discharging and checked whether the compliance with respect to the standards. The number of guard ponds, the procedure is depending on their volume of effluent that they generate. They provide the guard ponds. All the treated effluent are collected into guard ponds. This Andhra Organics Limited has 4 guard ponds and the volume is given there. And Andhra APL and Lantec, SMS, Divis. So depending on their volume of effluent generated, they have the guard ponds to store. Mostly this 1 week capacity is there to store. Next one. These are the parameters stipulated in the consent order. pH, total suspended solids, total dissolved solids, chemical oxygen demand, fluoride, phenolics, phosphate, ammonia, nitrate, hexavalent chromium, heavy metals like arsenic, lead, cadmium, chromium, and copper, zinc, and ferrous, manganese, and nickel. The temperature issue comes only in respect of cooling water disposal, sir. Yeah, it's a normal temperature, ambient temperature only. All are disposed in the ambient temperature conditions, sir. So some industries, because of the dilution factor, TDS is given. It's not uniform. Actually, CPCB not mentioned any TDS, but in our consent order, depending on dilution factor and currents that are available in the disposal point. So taking those factors, we have yes, sir. The reason is, sir, it has to quickly reach the baseline concentration. If the higher concentration is disposed at that point and within 50 meters of the both sides of the disposal point, the baseline concentration has to be reached. That is the reason we also stipulate sometimes. For some industries only we did it, and not for all. Yeah. Sir, APPC developed standard operating procedure, sir, in the year 2019, sir. I remember, sir, the first meeting you have held it, sir. You ordered for this SOP to have it. So since then we are following this SOP, sir. This is the first version, as you mentioned just now. First, for discharge of effluents under the direct supervision of board officials. Earlier it was not there, sir. Now, since 2019, it is collected into guard ponds and stored there, and the officials go there and open the seal, and then only after they take the samples for all the parameters, they check in the laboratory. After that, if they effluent comply the standards, then only they are allowed to discharge. Sir. All the marine outfall units were directed to arrange infrastructure as per the guidelines issued in the SOP, namely installation of online analyzers for pH, TSS, TOC, COD, flow meters, CC cameras, and IoT devices. These are the instruments we use, sir, analyzers for pH, TSS, and TOC, COD, flow meters also, magnetic flow meters we are using, web cameras, IoT devices. The treated effluents stored in the guard ponds are analyzed at journal laboratory for testing compliance before permitting discharge through marine outfall. Next one. Hardware, sir, webcams, flow meters, level indicators, online analyzers, and marine app and real-time pollution monitoring systems. Sir, through webcams, we are able to see from our office and keep monitoring what is happening all around the ETP and surrounding, and guard pond status and volumes present in that. And flow meters also are tagged to the, and the data is uploaded. Come to know the flow levels while discharging also. Level indicators in the guard pond also indicate the volume of effluent. Online analyzers for the parameters, sir. We have a marine app also to capture the field data. It is a mobile application. Next one. The protocol followed for marine discharge. The marine discharge pipeline pump, the inlet and outlet of the guard ponds are locked and under the control of marine discharge officials. The board officials only keep controlling on the guard pond, both inlet and outlet, and the pump also locked, sir. Sample of treated effluent stored in guard pond is collected, coded, and sealed as per the SOP and submitted to APPCB laboratory. Sir, after the officers who collects the sample, that is coded, sir, there itself, and also brought to the, because the confidentiality is maintained where from it is collected, that is not divulged to all other officials who carry the sample testing. The marine discharge is permitted only on compliance with the discharge standards and under the supervision of APPCB staff after verification and data recording of on-site parameters like flow meter, readings, level indicators, and guard ponds. So this data is captured at the field level and also loaded onto the app and stored in our server. Sir. The treated effluent that exceeds the discharge standards on laboratory testing is rejected for discharge and is recirculated to ETP by the industry for meeting compliance. Sometimes when we take the samples, the sample doesn't comply the standard. Then the effluent is taken back to the ETP for further treatment and again retested for compliance, and then only it is permitted to discharge. Sir. On complete, pumps are locked and sealed with the signature of the officer on marine duty. The inlet of the guard pond is open to facilitate the flow and the storage of treated effluents in the guard pond. Next one. Presently, APPCB is monitoring the marine outfall industries through physical inspection, sampling, for verifying compliance of marine discharge standards. In addition to this, online continuous effluent monitoring system installed within the premises of the industry. Sir, actually we have a mixed mode, sir. That physical inspection is carried and data is collected, sample and data is field data is collected, and physically the pump and outlet of the guard pond is open on compliance with the standards. At the same time, we also have the online monitors system, sir. Until it is completely end-to-end digitized and established its reliability, we are having the mixed mode, sir. The SEMS provide continuous monitoring throughout the duration of effluent discharge through marine outfall. The online instrument output is uploaded to APPCB server. If any deviation is observed at the outlet of guard pond, discharge is stopped physically by the officer. Presently, the discharge is stopped physically, sir, because it is not facilitating. Even from APPCB server, a signal is triggered, but it cannot be, motor cannot be stopped instantly. So we are following this physical mode only to stop the discharge, sir, whenever it is exceeding. APPC is planning to end-to-end digital online continuous monitoring by installing automated technologies. At present, SAMS is installed within the premises. Now APPC is planning one more SAMS outside the industry premises for double check. Sir, actually, whatever is happening in industry premises, I just now told. And so apart from this, to have a double check, outside the industry premises also we want to monitor the pipeline which is discharging into sea. So we will have another marine monitoring station with all these systems, same web camera as well as online instruments. So that will give a double check, sir, if any of malpractice is done. Next one. Parameter accuracy, allowed variability. These are CPCB stipulated procedure we follow, sir. COD accuracy, BOD accuracy, pH accuracy, and TSS accuracy. Next one. Data validation for COD, BOD, and TOC and TSS. So validating the data, whatever is captured by the online instrument is important. So a frequent calibration, whatever is stipulated in CPCB, that is how we are following, sir. Online instrument operation will be evaluated by validating sensors and probes with known traceable standards using laboratory techniques. Our field staff go there and calibrate the instrument, sir. If variation is outside the set points of known standard, then system requires calibration. So we will ask them to calibrate. Again, also we will also check the calibration, and then we will only put to use online. Frequency of the validation by the industry should be once in 3 months or as specified by the manufacturer, whichever is earlier. The frequency normally is in 3 months, sir, for COD, BOD, and TSS. For pH, it is a weekly one, sir. Next one. So these are the statistical data indicating each of the industry, and the samples collected, and the yellow shows the rejected, sir. So small portion of the samples are rejected. In that case, we also send the effluent, ask them to send the effluents to back and get treated, sir. Next one. As sir mentioned just now, the post-discharge scenario that we want to know, sir, that it's in conformity with the requirement, because we want to know the impact of the marine outfall discharge. So we have asked the NIO to carry out studies, oceanographic surveys to assess the environmental impact between Paidipamvaram to Nakapalli zone of North Andhra coast and establish the health of the environment surrounding the marine outfall. So the previous study, the outcome of the previous study by the NIO is, NIO study indicated that there is a marginal impact of industrial effluent discharge on water quality with slight depletion in DO levels in the near zone. That means the outfall points, near to the outfall point there is a depletion, but no effect observed on the abundance of phytoplankton, zooplankton, and benthic organisms in the study region. So NIO confirms, sir, that there is no much impact other than the DO depletion. Next one. This is the flow chart, sir, what we are following, and also the future plan for this. This is a guard pond. From ETP, it goes to guard pond. From there, the discharge valve is controlled by our officers, and whenever they leave the premises, officer leave the premises, that is locked and sealed, sir. We have at present only online system within the premises, sir, where pH, TSS, COD, and BOD captures and also upload it to the data. But in future, we want to, outside the premises, we want to have one more system, sir. End-to-end digitization is the final target, sir, but that will take time because the availability of the technologies is the limitation now. Next one. Thank you very much, sir. If anybody has any question, let me know. Yes, sir. We break for tea, arranged outside. Please join for tea break. It's for 15 minutes from now. Yeah. Even if we come back early, also fine. I request everybody to take seats. We will start next topic. Srinivas. All of you, please join the next topic. We'll start the session. Those who are outside, please join. Yeah. Yes, sir. The next topic for this session is zero liquid effluent discharge. Mr. Thakur Parwani is supposed to come, but he didn't come for his schedule, change in schedules. And Mr. Sabba Sridhar, EHS head of DRL, please join and make a presentation.
So, good morning everyone. I would like to thank you all for taking your time. Before starts the presentation, let me introduce myself first. So, I am Sridhar Sappa, taking care of environmental operations and compliance of Dr. Reddy's Pidebevaran cluster. So, I have 20 years of experience in environmental operations in pharma sector. So, let me share you the environmental management system which the Dr. Reddy's has adopted. So in this presentation, we will cover what are the process operations we have considered in the zero liquid discharge and how the new technologies which we have intervened in the conventional effluent treatment plant, the handling of sludge generated from the zero liquid discharge and air pollution control measures which we have considered in the zero liquid discharge. So as you all know, Dr. Reddy's presence is in global. So we have 6 API manufacturing units in India, out of which 4 manufacturing units in Telangana region and 2 are in Pidebevaran cluster, Visakhapatnam, Andhra Pradesh. So we are the front runners in pharma sector, which we had adopted zero liquid discharge in 2004. We have a dedicated treatment facilities for process and as well as non-process. So all our facilities are equipped with zero liquid discharge and is being monitored by the highly qualified and experienced environmental engineers. So we strongly believe that to run the effluent treatment plant successfully, the segregation of effluent streams is the must. So we have developed a robust mechanism at production blocks itself. So segregation is been taking place at production blocks itself, and the segregated effluent is been collected into the above ground effluent collection tanks, and the effluent generated at zero level, like effluent generated from the clean rooms. For that, we have a tank-in-tank concept. The effluent has been pumped from production block to zero liquid discharge through above ground pipeline in a concealed manner. So we have ensured by design itself that there is no contamination while transferring these effluents.
So are you separating out the process and non-process, or how are your pipelines are different?
From the source itself, we have segregated, sir. We have a separate pipelines at reactor itself. So there, we segregated based on the qualification. If the COD and TDS levels are more than 10,000, we consider it as high TDS. That I will cover it in the next slide. So we have choose operation process methodology in effluent treatment process like physicochemical treatment plant, biological system, filtration, reverse osmosis plant, and evaporation systems. For each and every stream, we adopted different methods. So this is the outline of our zero liquid discharge. As I said earlier, we segregated the effluent streams at production blocks itself. We have segregated our effluent streams as a 4: process high TDS, process low TDS, non-process, and domestic. For process effluent, the COD is more than 10,000 and TDS is more than 5,000. We consider it as a high TDS effluent. For low TDS, below that, we consider it as a low TDS. For non-process, effluent generated from the cooling towers, softener rejects, water block rejects, we consider it as a non-process effluent. Domestic, we have a dedicated STP plant. That is the reason we have not covered up in this slide. As I said, we have considered physicochemical treatment process. For each stream, we have covered physicochemical treatment. So at physicochemical treatment system, we have a oil and grease separator followed by the equalization and then neutralization. So the effluent which comes from the production blocks, it has to pass through the oil and skim chamber. There we segregated our oil and skim. After that, all different effluent streams has been equalized, and then we will neutralize if required. So after that, we will do the chemical treatment system where we have added polyaluminum chloride as a coagulant and polyaldehyde as a flocculant. After that, we pass it through the primary clarifier where the sludge will be, flocculants will be settled down and the treated water will be carried out into the holding tank. The entire primary treatment system concept is to eliminate the total suspended solids so that these solids will avoid some hindrance in the next continuous process. So for ITDS effluent, after the primary treatment system, we adopted stripper, multiple effect evaporator and ATFD. At ITDS effluent, the possibility of solvent contamination is very high and the volatile compounds is also very high. So that is the reason we have passed through the stripper, where the steam is given and the evaporated stripper VOC will be condensed further and the enriched stripper will be sent to the cement industry for co-processing. So the stripper bottom will be given to the multiple effect evaporator, where we have a 6 effect multiple effect evaporation system in which 4 are falling film and 2 are forced circulation. Generally, our high TDS effluent characteristics is like our TDS will be in 40 to 50,000 and COD is 50,000. So where it comes to the stripper, the enriched solvent is 70% of solvent content and 30% of water will be there. So near about 9 to 10 lakhs of COD will be covered in this stripper distillate. So the remaining stripper bottom will be forwarded to the ME, where the TDS concentration will be 5.3%, and after falling films and after forced circulation, the TDS concentration has enriched to 40%. So that 40% of further concentration we will fed into the ATFD, agitated thin film dryer, where we remove the solids and we will dispose it into the cement industry for co-processing. So the condensate generated from the multiple effect evaporator and ATFD is again been treated into the biosystem along with the process low TDS and non-process. For low TDS also we have a primary treatment system. And then we have a holding tank. Here we will mix the ME condensate, ATFD condensate and this non-process effluent. Here, sir. So this neutralization effluent will be fed into the bioaeration system. Here we have a two-stage biosystem. We used to maintain the hydraulic retention time of 5 to 7 days, where the 95% of BOD removal is achieved in this biosystem. After biosystem, we have a treated water, which the COD is having 500, and the TDS is near about 5,000. So after biotreatment system, we have a filtration setup, sand filter followed by activated carbon to remove any dead sludge particles. Then we will feed into the reverse osmosis. So we have a two-stage reverse osmosis. In first stage, we achieved 80% of recovery in this RO plant, and the RO1 reject is further passed into the RO2. There we have a recovery of 50%. So the permit of RO1 and RO2 is being recycled back into the utilities. So RO1 permit quality like TDS is having 250 and COD is less than 20. So this is directly we fed into the boiler. And for RO2, there is a slight increase in TDS, near about 750, that we are giving it to the cooling towers for a makeup application. So whatever the sludge generated from the primary treatment system of high TDS effluent and low TDS effluent and for non-process, we take it to the sludge thickener. From then, we operate it through the decanter, and the thickened sludge is being sent into the cement industry for co-processing. So this decanter scented will again taken back into the low TDS for biotreatment. So this is the overall outcome of our ZLT treatment. So here we ensure that the entire effluent is being recycled back and the solids generated is being disposed to the cement industry for co-processing. LT, sir, here actually whatever the RO rejects, final RO rejects, we used to treat it into the multiple effect evaporator. So we have this is the new technology, low temperature evaporator. Now RO reject is being handled into the low temperature evaporator instead of multiple effect evaporator. The advantages of this LTE will be discussed in the later slide. So with this entire treatment system, we sustained complete zero liquid discharge. So again, we thought that some new technology will be introduced into the existing conventional system so that we can sustain the performance, effluent recovery performance for a longer run, and simultaneously OPEX, operation expenditure, can be reduced further. So we have explored the various technologies and we have introduced into this technology into our conventional treatment system. So multi-disc press is replacement of the conventional decanter, And low temperature evaporator is a replacement for the multiple effect evaporator. And some heat integration has taken place in the stripper. Thereby, we have reduced steam consumption in the stripper. So, advanced oxidation is one of the process. Recently, we have taken a trial. So, the trials were successful. That is also we will speak it in the later slide. So, the advantages of screw press. In conventional, generally the sludge, whatever the sludge developed in the ATP treatment plant. Earlier, we used to treat it into the decanter centrifuge. Now, this is the multi-disc screw press where it is a high energy intensive equipment. In earlier decanter centrifuge, our power consumption is 18 kilowatt, whereas with this screw press, our power consumption is 5 kilowatt only, 5 kilowatt. And in earlier decanter centrifuge, the moisture content is 70 to 80%. With this multi-disc screw press, we are able to achieve the moisture content is 70%. So, so this is the low temperature evaporator. Earlier, whatever the process RO rejects, we used to treat into the multiple effect evaporator, where we required huge steam consumption. This is the low temperature evaporator, which works based on the principle of compression, evaporation, and condensation. So initially, steam is required to start up the plant. Once the vapors release, that vapor will be compressed through mechanical vapor recompressor. That compressed vapors will be again fed into the system, and that will preheat the feed, and again it will condense. The vapors will be condensed. So with this, we have eliminated the cooling tower requirement, and we have reduced the steam consumption like anything. And if you see the power consumption in earlier power, with the multiple effect evaporator, the power consumption is 35 kilowatt per KL, where with this LTE, we achieved 24 kilowatt per KL. Steam consumption, in earlier multiple effect evaporator of steam consumption is 350 kg per KL is the requirement. Now the steam consumption has got down to 5 kg per KL with this LTE. So next is the advanced oxidation. This is still in initial development process. We have taken trials. So the trials were quite encouraging. So this is the quite replacement for the biological system. So because of this low retention time, generally the COD reduction will be achieved within the 3 minutes of retention time. So with this low retention time, generally the entire component will be come into the modular stage. Now in conventional biological system, we require a huge area for civil construction and other thing, whereas it required very small area. So 80% of CO2 reduction we have achieved in the trial process. So this we are going to implement in further. So the generated hazardous waste from the ZLD like ETP sludge and evaporation salts, we have a dedicated storage facility. We have complied the government norms. We are disposing it to the cement industry for co-processing. We are sending it through the online system in APMCL portal. Whatever the vehicles we have adopted, it's a GPS tracking, and those are registered in the APMCL portal. Air pollution control for ME vents and ATFD vents, we have connected to the scrubbers, where the pH is installed, and hypo or caustic is being used for the media. So that we eliminated the complete vapors. We avoid the vapor elimination in ZLD process. To summarize that, by effective segregation of effluent streams, selection of right methodology to treat the effluent streams and introduction of new technology has helped us to sustain the operations of ZLD in effective manner. Thank you. Thank you for your attention. So I would be very happy to answer the questions if you have any.
Only one question I will have.
Yeah, please.
In an incremental cost basis, how much do you think is the capital cost for the ZLD system? I'm not talking of the others right now, hazardous and all. ZLD systems, what is the incremental cost per KL or something in CapEx and OpEx terms?
Sir, in OpEx part is concerned, we have a treatment cost separately for both process and non-process. For process effluent, our treatment cost is near about 1700 to 1800, and it will vary depend on the steam cost. The steam cost is also vary depends on the coal price.
On an average, what
On
is
an
it?
average, our hydrogenase treatment cost would be 1700
1700 rupees per KL.
per KL.
And
Whereas
the capital cost for all these equipments?
it would come near about 30 to 40 crores, sir.
30
That's
to
stripper, multiple effect evaporator and ATFD. Whereas if I have shown that low temperature evaporator, that cost is near about 3 crores. That 80 KL capacity which we have installed. That we have invested 3 crores.
Okay.
And that operation cost of that LTE, surprisingly, it's 200 rupees per KL. Yes, ma'am.
You have shown that ATFD residue,
Yes, ma'am.
and sludge. You mentioned that you are sending to cement plant for co-processing.
Yes, ma'am.
So I would like to know that sludge and ATFD residue, what it contains, whether it contains a energy content or material content.
Ma'am, in biosludge, generally the calorific value is greater than 2300. So as per
Okay.
the norms, if that more than 2100, it can be sent it for the cement industry.
Okay, for
co-process.
that sludge. Okay,
Yes, ma'am.
fine.
For ATFD salts, what we have done that, we will premix with the organic residue. That is called, what we call it as a pre-processing.
Uh-huh.
After pre-processing, we are feeding it to the cement industry.
No, actually in ATFD residue, what we expect, it's like a inorganic salts only.
Yes, ma'am.
Okay, so inorganic salts means then it is not having any material content and it is not having any energy content also. For co-processing, these two things we have to look into. Whether that whatever the waste we are sending to co-processing, either it has to be material content or energy content.
Yes,
So then how you are by substituting other organic, how you are increasing that material content. So that's what that analysis.
No, we are-
So
no,
please,
we are-
it is informed to ABPCB. You please look into these things because that ATFD salt recently I heard. Then how come they are sending to co-processing? We would like to know. Okay.
that
But
is the-
ETP sludge, okay. If suppose if they are using a honey lime, then it will be having a material content and as well as the energy content that can be sent to the co-processing. But ATFD salt, I'm sure that it's a inorganic.
Yes, ma'am.
Okay, you are also agreeing.
We do
Huh.
accept.
Uh-huh.
But here what we done is,
Huh.
we premix with the organic residue.
No,
So
that's
that,
what you please
so
ensure that,
we will
sir.
mix it in such a composition that it will process it to the cement clean.
Madam, as you said, the CPCB criteria for pre-processing is while sending waste, particularly the solid waste, when 2,500 calorific value is there, that has to be incinerated, remaining for landfill. That is the criteria even CPCB prescribed. So the point here is premixing of ATFD salts with the organic. So you are raising the calorific value, is it?
Yes, sir.
How much is that?
That would be more than 2,500, sir.
Yeah, that is what happening, ma'am. I think technically it satisfies the requirement.
Especially this ATFD salts, they are sending to the TSDF only. So no, that's what here how that pre-processing unit and then how your monitoring mechanism, what type of monitoring mechanism you have that you have.
No cement plant will take it in case it does not meet the requirement. And it's simple because that is the thing. So, now most of Europe, they are moving out of the TSDF. They are now increasingly going towards, putting it to some use, whatever it is. So they have come out with a tech. I'm sure the technology will keep on changing.
Yes, sir.
But what they are saying is they are mixing it with some organic substances to increase the caloric value and then putting it in the.
Yes, sir.
Is that correct?
Yes, sir.
European countries now not operating the TSDF, now they're closing the TSDF in European countries, madam. They are increasing for after pre-processing, they're increasing for co-processing. First they have to pre-processing and they have to increase in co-processing, you know very well.
No,
We
I
are
know
also
very well, sir. I know
general-
very well, but other ways, but ME, that ATFD
Yes, ma'am.
residues.
Yes, yes, madam.
So CPCB is not having any database regarding this. That's what we would like to. So as of now, we don't have any, and then.
For that they have given.
Because it's a completely inorganic salts.
Yes, 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 madam.
Completely inorganic salt.
Okay, okay.
We are always behind technology. Technology is moving faster than us.
Yeah. Of course.
Yes, sir. Sure, definitely. Yes, sir. So this advanced oxidation is a two-stage process. As I mentioned, the basic principle is static pressure difference and electro-oxidation. Once the effluent has been passed through the venturi, then the high complex molecule will be split into the bubbles. So this will help us to oxidize in the second stage, where the oxidation happens. Yes, sir. No.
Yeah, my question is LTA about low temperature
Yes,
evaporator. What is the TDS limit for the inlet and what is the TDS limit for the outlet?
So TDS actually we have considered for 5%. Now we are operating at 4%. So the output concentration is 30%. You can go up to 40%. It's your requirement.
But what about
Only thing-
precipitation of salts within LTA?
Yes, sir. That again it depends on your characteristics in your effluent. If you have a high hardness, then definitely precipitation will happen. If it is exceeds saturation limit, then you will get precipitation. So we need to check that precipitation rate and then we need to act.
So there are circulation pumps like MEE in this case also?
This is the
tubes
basically
and
falling
circulation
film.
pumps?
This is the falling film, sir.
Okay.
This is the new technology that's now it has been further tuned. Now falling film and force circulation is also available in this LTE.
The main purpose why we requested this was that, people should start thinking about it. As the time goes, we don't know what all are the restrictions going to come. So these are the types of thinking. I am sure they have adopted some technology. There will be 101 more technologies coming up. You will have to do the main research on that. But this is just to enlighten you think. May I just request you, Mr. Srinivas, one thing, that if you can just give us a small presentation, not small, detailed presentation, 20, 30 slides with all this ZLD process. We'll put it on, if you don't have any copyright thing, we'll put it on our APPCB website for anybody to take information on this ZLD processes.
Sure, sir.
Okay?
Sure,
Thank
sir.
you. Thank you.
sir.
Thank you, Mr. Sridhar Garu. The next topic is segregation of waste streams and treatment methodologies for safe marine disposal by Sri Dr. Venkat Sastan Raju Garu, Executive Director, Deccan Fine Chemicals. I just want to bring to your that all this will be made into a souvenir and that will be supplied to you later. And soft copy also will be supplied.
So good morning to all dignitaries and colleagues from the industry. So this is, the presentation is on the segregation and treatment of various waste streams for manufacturing units having marine discharge facilities. So the segregation of waste is same as explained earlier. This is high TDS, high COD streams. This is mainly comes from process plant, water contaminated with inorganic salts, dissolved organic solvents and various chemicals and emulsions, high TDS, low COD streams, utility blowdowns, secondary scrubber bleeds, low TDS and high COD streams. The source is water washes, blowdowns from ejectors, watering vacuum pumps, and other washings from the floors, etc. Then organic residues. Anyway, organic residues, they are treated separately. Can you go to the next slide? So here, what I consider is, have to press this, huh? Okay. So here, the treatment of this high TDS, high COD waste, that is the most complicated, I know that as per my experience. So normally in the process, what happens is, from the reactors, when inorganic salts are formed in the reaction, then water is charged and the salts are dissolved in the water and then separated out. That is called as a workup. One of the operations. We call it as workup. So these aqueous layers are contaminated with inorganic salts, emulsions, and soluble organic solvents and other chemicals. So here, isolation of emulsion by decantation, gravity separation from reactors, this is very, very important. This has to be done within the process plant itself. It is not part of the activity in the effluent treatment plant. Within the process plant, these emulsions have to be separated and then recycled properly. And these emulsions shall, in any case, shall not go to the storage tanks, waste storage tanks. And then one challenge is in soluble organics. In most of the chemical industries like multi-drug industries and then dyes, pesticides, we use a lot of solvents like dimethyl sulfoxide, then NMP, like that, which are highly soluble in water. So isolation of these solvents is a challenge. The performance of the effluent treatment plant depends on how efficiently these solvents are isolated within the manufacturing facility. So we, in case of Deccan, we distill out all these soluble organics. We have large, long distillation columns with the structured packings designed by Schulzer. We separate out all these organics within the process plant itself. Then after that, those organic solvents are recycled back. These organic solvents are highly valuable solvents. Actually, the cost is varying from 80 rupees per kg to about 2000 rupees per kg. So the money spent on recovery of these solvents is far, far less compared to the value of the solvent that we recover. So these solvents are recovered and then recycled back. So after that, this waste stream is taken into the storage tanks. So here in our plant, when we started our manufacturing in the year 2010, that time we used to have some PPFRP and MS tanks. Now we are not going for MS tanks at all. We are not happy with PPFRP also. So all our waste storage tanks are made of stainless steel. They are all made of SS stainless steel 316L. So you can see here, and we have to treat, we have to respect all these waste streams. And there is a dike wall around the tanks. Those dike walls, they are designed to hold the entire effluent. If any of the tank, there is a failure of any of these tanks. Then we use pumps with mechanical seals, and then all the piping is above ground piping. We pump these respective streams for various treatments. So this is another photograph where we have where the pipe racks are shown. So all the pipes, they pass through the pipe rack. So the most important point that I want to make out here is going for stainless steel tanks is highly recommended. They never fail. Then there is another waste stream. Normally we don't consider this, they take it very seriously. It is not known also. So here what happens is, we use of course multi-stage scrubbers in all our process plants. And here we use caustic, water, dilute acids as scrubbing liquids in these multi-stage scrubbers. So all common vent headers from the process plant, they are connected to these scrubbers. So vapors from these common vent headers contaminates the scrubbing liquids, causing high COD and also reduces the life of packings in the scrubber. Some packing material is provided in the scrubber for effective scrubbing. Then uncondensed vapors from vacuum systems is a source of major contamination. So this is just an indication. All tanks, whether it is reactors or storage tanks or any equipment in the plant, they are all connected to a common vent header, and the vent header is connected to scrubber. So normally in vacuum operation, most of the contamination takes place. So we have, there is a reactor, and in general we use 3 condensers. We don't shop with 1 condenser. We go for 1 condenser with cooling water, which is the cheapest utility, and then chilled water followed by chilled brine, which is the most expensive utility. So 3 condensers are there. And then after that there is a vacuum system. So normally what happens is steam ejector or watering vacuum pumps, they are the most widely used for getting vacuum. So from there, a lot of these solvents escape. And then the solvents, vapors will enter into the common ventilator system and then to the scrubber. So because of the contamination of the scrubber water, then the treatment of that will become very difficult. So this is just a comparison between steam injectors, watering vacuum pump and oiling vacuum pump, which are widely used in industry. So in case of steam injector, the steam is a motive fluid and the steam gets contaminated with the solvent. In case of watering vacuum pump, water is a motive fluid and water gets contaminated with various vapors, solvents and other vapors. In case of oiling in vacuum pump, same is the problem. Oil contaminates with these vapors. So this is the picture of the ejector. So normally what happens is you can see the motor stream which is coming from the top and the suction is from the side. So the vapor and the steam gets contaminated and it comes out, and treatment of that is a big challenge. So this is watering vacuum pump. Here also what happens is water is the motor fluid. This water gets contaminated with various solvent vapors, organic vapors. So then what we are doing in our case is we don't want to allow this contamination. So the solvent from exhaust or vacuum system can be recovered completely if there is no motive fluid, if you go for a dry system. So effluent generation from vacuum system can be avoided if solvent vapors does not come into contamination with motive fluid. And then usage of expensive utilities like steam cooling water, chill water not required in the absence of motive fluid. So what we have done is we have gone for this kind of equipment. This is made by Edwards. This is imported equipment from UK. So each pump, along with booster pump, costs about 45-50 lakhs, and we have more than 100 pumps in our factories. Probably, I think in the world, the maximum number of Edwards vacuum pumps are within our factory premises in the world. That's what the supplier says. So this is the dry vacuum pump, and there are two classes which rotates at very high speed and creates vacuum. They rotate at very high speed. So here, as I mentioned, there is no motive fluid, then no steam is required. So then solvent from exhaust can be condensed and recycled back, sir, because there is no contamination. The solvent which comes out, you can see a condenser here. The dry vacuum pump is out here. Here connected to another condenser. So the solvent is condensed there, and then it is completely recycled back. And outlet of that condenser only is connected to the common vent head. So this is to minimize organic vapors. So that's how we are reducing organic vapors in the contamination of scrubber liquids with organic vapor. I think this slide is not very, very clearly visible, but it is more or less in line with the Dr. Reddy's slide. So, sir, this high TDS waste, whatever I mentioned, high TDS ICOD waste, after recovering all this soluble organic matter, we connected to a stripper. There is a stripper. We use very large stripper. This is about 25 meter side, and the diameter is about 1200 mm. So there, any other organics that are present, they are completely removed. If you don't remove that, then that will affect the balance operations, sir, downstream operations. So these are our multiple effect evaporators. We are using these multiple effect evaporators mainly for this high TDS ICOD waste. So they are like almost, they are about 700 KLD capacity each multiple effect evaporator. Each one is like a production block only, sir. And then we have agitated thin film dryer as well. Then the distillate from this multiple effect evaporator and other waste streams from the plant, they are taken to again the effluent treatment plant. So the oil and other separation is same as what the Dr. Reddy's representative explained. And then we have gone for clarification, utilization, primary clarifier. We have gone for two-stage bioreactor system. So this is the most efficient system in the effluent treatment plant, but at the same time more very, very delicate. So here we have to ensure that the TDS, salt content in the effluent, is less than 8,000 milligrams per liter. That is very important. So this is working very well. So the treated effluent from primary, that bioreactor 1 goes to primary clarifier, and then it goes to bioreactor 2, and then secondary clarifier. And then finally there is chemical treatment. And then treated effluent goes to the guard pond. So this is how our effluent treatment plant looks like. It is huge, sir. I think it is a very big plant and completely above ground. So what you see here, everything is completely above ground. it is very, very clean and neat and odor-free. This is the lab. This is the lab in our effluent treatment plant. So here I would like to briefly show what is it that we have. So for online TOC measurement, so what we do is we have taken a tapping from the discharge of the pump, marine outfall pump. And the discharge of the marine outfall pump that goes to the online TOC meter. So you can see here, this is online TOC meter. From this pipeline, it goes to online TOC meter. Then this online TOC meter, here this is imported to online TOC meter from Shimarju. This measures the flow. So here, what happens here is, sir, this effluent comes from here, and then excess treated effluent goes out, and this flow meter, this one online meter, it draws some from this pipeline. So then the outlet from online TOC meter is connected to a tank there, so where other parameters are also measured, where like pH, total suspended solids, etc. And an outlet of that small buffer tank is connected to another tank, and then from here it is pumped back to the effluent treatment plant. So here, so this operation is very, very important. This leftover collection tank is there. From here we have to pump it to the, again, effluent treatment plant. So some of the challenges that we face here is, this online TOC meter has to be absolutely, it needs dust-free environment, and temperature control also is needed. So it has to be in a closed room, preferably in an air-conditioned room. Then pure air is required, instrumentation air. And TOC meter is about 1.5 meters height and 0.5 meters width, the dimensions of the TOC meter. And continuous flow of treated effluent is needed. We have a small pipeline about 15 mm diameter. So from the discharge of the marine outfall pump to the connected to the TOC meter. So the pipeline tapping is taken from metal pipe. We have used metal pipe only. Here, the important thing is we minimize number of tappings from the HDPE pipeline, because HDPE is delicate compared to the metal pipeline. So we have taken tapping from the discharge of the pump from the metal pipeline. And the flow rate of the pipe, flow rate of this treated effluent from the pipeline to TOC meter is about 2000 liters per hour. So out of that, a small portion TOC meter takes. And then the excess quantity, it comes out at a pressure of about 2.5 to 3.5 bar gauge. And then what happens is outlet from this, from the inlet of TOC meter is connected to a tank that I have already shown. So here what happens is every day about 30 to 50 kL of treated effluent gets collected at the outlet of TOC meter, which needs to be again pumped back. So this is, this has to be taken care. And any malfunction of any equipment, any failure of the pump, while pumping it back, that results into a leakage of the treated effluent, whether it is within the plant premises or outside the plant premises. So the discharge from the tank near online TOC meter is connected to another tank that I have already shown to you, sir. And if monitoring of TOC is done round the clock, about 48 kL per day of treated effluent will get collected in a day. This needs to be collected in the tank and pumped back to ETP or marine outfall system. Any tripping of the pump due to power failure or fluctuations will result into overflow of the treated effluent. The HDPE pipeline near the proposed monitoring system, which is now, see right now what is there is as per the standard operating procedures, part 1 given by AP Pollution Control Board, which is considered to be very, very good and very well appreciated across the country. So what we have done, sir, we are following it strictly. And anything that is done within the factory premises, we have the control, complete control. But what happens is, once it is outside the factory premises, then what happens is to take the sample and we have to expose the pipeline. We have to, right now the pipeline outside our primary factory premises is 1.5 to 2 meters depth. So now we have to dig it out and then expose the pipeline. See, our experience I will share, maybe others also have similar experience. We used to draw water from infiltration wells of Tandwa River earlier, sir. So this, some unsocial elements, they used to intentionally damage the pipeline many times. And when there was an unfortunate incident in our factory, they have even burnt the pipeline. It came in the news channel also. So we are operating our plants in the middle of such people. So now what happens is our apprehension and I know whatever with the money, whether the Pollution Control Board spend the money or we spend the money, there's a lot of value in it. Our apprehension is the pipeline which is exposed outside is going to be the most delicate path and villagers are likely to damage it. I'm telling you 99% they will do it. There are marker buoys, sir. So far we have installed 6 marker buoys. For example, at the discharge point of the marine outfall, there is a marker buoy and with a stainless steel chain. So they go into the sea and then cut off the pipeline. So if they get some money to have one bottle of drink, that is enough for them. Then so far, many such marker buoys were stolen away. Same is the case with other industries also. So anything outside our factory premises is not in our control. And it will be very, very difficult for you also, for the Pollution Control Board also to have control in that area. So kindly think about it, sir. This needs some discussion. Then about this bioassay, I don't want to take much time, sir. I don't have expertise in this. But the only one point that I wanted to mention here is earlier we had actually as per the earlier bioassay procedure, test procedure given by CPCB, we were permitted to use 7 different types of fish. But now they say we have to use only zebrafish. We are finding it very difficult to get it in the market. So I request ma'am, please see, ma'am, here as per the old standard given by the CPCB for bioassay test, 7 different species were allowed to use. But now I think they are insisting to use only one species. There was some circular or something like that, zebrafish. And we are not getting that fish. There is shortage for that kind of fish here. We are not getting it. So if we have more choice, that is better. This is my request. Kindly consider. Then this I want to skip, sir, because there is another important thing that I want to show. Sir, actually last time when Central Pollution Control Board proposed draft standards for pesticide industry for discharge, and then we have a lot of deliberations with the Central Pollution Control Board. I am very active with many industrial associations in the country at national level, sir. So then CPCB suggested to us to collect the actual data from major pesticide industries. Then we did a lot of study also. We have done a lot of literature survey and all that. What we realized, sir, if you see that there is US EPA standards are there. So US EPA standard, the first column shows the effluent limitations per kgs per 1,000 kgs of active ingredient. US FDA. They say COD and BOD in terms of kgs per 1,000 kgs of active ingredient. So it is COD is 13 on per day basis and 9 on annual basis, on monthly basis. So what it means is about 50% hike in a day, suppose is allowed. US EPA allows that. But whereas in our case, 250 mg per liter means even if there is a slight sudden spike up to 260, 270, it is considered as a major deviation. Whereas in US, this is for marine discharge only, sir, available on the internet, on the public domain. So on a daily basis, up to 13 spike is allowed, but monthly average shall be on 9 tons per day into 30 days, like that. So similarly for BOD also is that. So when we have collected data from 18 major manufacturing facilities in the country, then I myself surprised. So the COD, what we are getting now after treatment, is 4.39 to 6.19 kgs per kg per 1,000 kgs of active ingredient, which is lower than that of US EP elements. And same is the case with BOD also. Now, we had a detailed discussion with Mr. Tanmay Kumar also, the chairman of CPCB, on this matter. Now, MOIF and CPCB, they are, considering this. It will take time, but they are studying this also, going for quantitative standards instead of qualitative standards, like 250 mg per liter or 100 mg per liter, whether we can go for this kind of standards in India. So, like, kgs of a COD per ton of active ingredient, that is being explored, but it will take time. But what I would like to highlight here, sir, for me, this is a very big surprise. Right now, the standard that we have in India are much more stringent than US EPA standards. That is, that's how we are. Then this we came to know after thorough study, sir. Now what is the latest development? What is happening post-COVID is all our customers, and they are asking us to get the sustainability studies done. Now the focus is on minimization of green gas emissions. So that is the main focus, sir. So as per the direction that we have got from them, we have engaged this E&Y, Ernst & Young, some international agencies, to study what is the present status. And this has to be again verified by a second independent authority, independent auditor. And they have given what the present position is. From now onwards, every year we have to show substantial improvement in the reduction of these emissions. And this has to be applied across the supply chain. See, Deccan has got maybe about 100 suppliers. Now we have to see that they also implement this reduction of these greenhouse gases. So this is one thing which is good for environment, there's no doubt. And we are forced to look into other technologies, sir, as you have mentioned. We are forced to look into other technologies to reduce energy consumption, to reduce waste streams and all that. So this is one very, very serious thing that is going on. If we don't show progress, we won't get business. That's all. There is no negotiation in that. That's how it is, sir. So we, all stakeholders in the supply chain have to be strictly, they have to strictly focus on that, and then compliance with statutory regulations by adopting cleaner production technologies is the only way. So out of this today's workshop, one realization that I thank you very much, sir, for arranging this workshop. The exchange of ideas in environmental production is very much essential across the industry, sir. Otherwise, today Dr. Reddy, he has made a good presentation. He has told about couple of new technologies that they are going to adopt. Similarly, we also have much more. Because of time limitation, I could not show all those things. And many other companies might be having much more. They might have already learned. Otherwise, what is happening is suppliers are cheating us. They say this is the best technology, this will work. And we spend a lot of money, it won't work. Then we face problem. So I request Pollution Control Board, because why I am telling you, sir, APPCB has got a lot of respect and of course fear also. And when you conduct the workshop, then all industries will come. There is no doubt about it. If that is done, and if we can exchange our ideas, one-day workshop, we don't mind to sponsor, sir. Industries will sponsor. Then that will really help us a lot. So thank you very much, sir, for giving me this opportunity.
Any questions from the participants? Yeah.
Thank you, Raj Garu, for a valuable information. Sir, my question is like in the effluent treatment, you mentioned like you implemented two-stage bioreaction. I mean, how it is different to conventional bioreaction? Like, is it something like a packed media in these two stages or something different?
Yeah, what we have done is, earlier we were, in the old system, we used to follow aeration followed by anaerobic. Treatment in the presence of air followed by treatment without air, in the absence of air. So that anaerobic, we have faced many challenges because that needs a packing media. And then over a period of time it gets clogged. Then you can't do anything. So here now what we have been doing is we are using the bioreactor system with a diffuse type membrane system. So there are circular plate type membranes at the bottom of these bioreactors from where the air is pumped with air compressors. So what happens is small air molecules, they pass through and the mixing is very good and it is very, very effective. So this is a very, very proven system. This we have seen at Dr. Reddy's and then we have adopted and it is working very well.
And what is the normal COD that these type of reactors can handle, sir?
See, I don't have exact numbers now, but I can say that the overall treatment efficiency you can achieve up to right from beginning to the end, from equalization tanks up to the tertiary treatment is about 96 to 97%. That is the efficiency that we can get.
Thank you, sir.
Thank you.
Okay. Thank you, Raj Garu. This debate about concentration-based standards as well versus this load-based standards is always there. There is need of a national conference on this. Maybe we'll gradually change over to load-based standards as is US EPA has done. Thank you very much. The next topic is effects of marine discharge on coastal environment by T.N.R. Srinivas Garu, Principal Scientist, NIO, Visakhapatnam. Please come on to dais. We are lagging by 15 minutes.
Yeah, good afternoon, everyone. Today, I want to present the impact of industrial effluent discharge on marine environment. I am from NIO, National Institute of Oceanography. Actually, this work is conducted in 2018 by APPCB is awarded this project, and we studied the industrial effluent discharge from north on the coast, nearly 16 discharge different points. That includes the Visakhapatnam port, Gangavaram port, and GVMC sewage also. And to study the effect of these effluents on the water quality, we used different parameters like physicochemical studies like temperature, salinity, pH, DO, dissolved oxygen, biochemical oxygen demand, dissolved inorganic nutrients like phosphate, silicate, nitrate, ammonium, and total suspended matter, petroleum hydrocarbons. And biological studies like phytoplankton, zooplankton, benthic planktons like macro and meiobenthos, and microbiological studies like total viable count, total heterotrophic bacterial count especially, and total coliforms, Escherichia coli like organisms, and Enterococcus faecalis. These two are indicator bacteria, and Pseudomonas aeruginosa, Vibrio like organisms, Vibrio cholera, Parahemolyticus, and several other different pathogenic organisms. And the study region is divided into 8 different zones, and the comprises different industries. The zone 4, Zone 4 mainly comprises Visakhapatnam port and Gangavaram port, and where the no industrial discharge point, only the port related and sewage effluent effect is there. And this is the sampling strategy where we applied OSPAR guidelines, where we collected samples from MOP point to 0.5 kilometers to 1 kilometer and 2 kilometers. And this is the zone 1 sampling map. We conducted similar way for the other 8 zones. And coming to the results, characteristic of coastal waters, relatively higher temperatures were observed in the pre-monsoon and compared to post-monsoon season. This is just seasonal changes only and of atmospheric temperatures. Relatively higher salinities during the pre-monsoon period compared to the post-monsoon, and this is due to the freshwater inputs of the northern Bay of Bengal due to equator-ward EACC currents. And no significant change in TSM pH was observed throughout the sampling area, but relatively higher chlorophyll was found during the pre-monsoon period than the post-monsoon, and southern part is having more chlorophyll concentrations. And the concentrations of indicator and pathogenic bacteria was higher in the and above the standard levels throughout the coastal waters. But and these are higher than the previous. Actually, we compared this study of 2018 with the 2011 study. There, the concentrations were higher in the 2018. And comparison to the DO versus BOD, DOD and BOD during 2011 versus 2018 studies, both pre-monsoon and post-monsoon, DO levels were depleted and BOD concentrations were higher during the pre-monsoon season especially, and compared to the 2011, indicating that increased organic input in the recent years. And this also supported by the undersaturation of the DO during the pre-monsoon season, and the mean is 81%. And during the post-monsoon season, waters are well oxygenated and BOD is also low, and DO saturation is also very high, 98% is showing. And similar observations were also in the other regions. And comparison of phytoplankton abundance with respect to MOP points to the other regions, surrounding regions, we noticed that relatively lower abundance was found in the MOP points compared to the surrounding regions. And similar data we obtained for the zooplankton and meo and macro benthos. And coming to this, main thing is the impact of effluent discharge on the ecosystem is significant only at the MOP point, nearly 0.5 kilometer surroundings, and it is increasing, the effect is decreasing towards the 2 kilometer radius. And morely it is, main impact is at 0.5 kilometers, nearly MOP point. And this, we conducted a mesocosm experiment in the coastal waters of Visakhapatnam, where we used nearly 2,500 liter capacity of the tanks, and these are deployed with the normal coastal water, and in the other tank we used, we added the effluent at the dilution factor, and we noticed that the bloom is taking place. And this is the experimental results where the chlorophyll concentration is increased at day 4 and day 5, and the nutrient concentrations are also high at the starting and they are decreasing, like nitrate, phosphate and silicate. And during the process, the POC, that is particulate organic carbon, particulate nitrogen are increased, and BOD is also increased at 4th and 5th day. And this is mainly due to the higher, the bloom mainly taking place due to the higher concentration of nutrients available at that this industrial effluents. Mainly the organic nutrients, nitrate, phosphate and silicate. And that is supported by the increase in the POC concentration and particulate nitrogen concentration at that particular period, mainly day 4 and day 5. And coming to the microbiological parameters, we studied different parameters, as I said, heterotrophic bacterial count, total coliforms, and indicator and pathogenic bacteria. And wide variation is observed in the heterotrophic bacterial count and other bacteria also. Coming to the indicator bacteria, especially Escherichia coli and Enterococcus faecalis, we observed higher concentrations at the northern stations. And one bacterial count, that the Klebsiella pneumonia, is observed at the southern station. And all these levels are higher the standard level what madam mentioned, that is 100 for 100 ml is more above than standard levels. And coming to the we tested for antibiotic resistance of the isolated bacteria also, and where we used nearly 21 different antibiotics as prescribed by CLSA guidelines for the Enterobacteriaceae and 14 antibiotics for the Pseudomonas. And mainly the most isolates showing highest resistance to H3-nom antibiotic, one particular antibiotic for both Enterobacteriaceae and Pseudomonas. And several isolates also showing more resistance to Cephalosporin family. But all isolates are sensitive to chloramphenicol, tetracycline, and norfloxacin antibiotic. And when we studied the ARI index and MAR index, multiple antibiotic resistance index, it is actually prescribed level is 0.2. That means greater than 0.2 means that the high risk source of contamination where antibiotics are frequently used. And here the industrial isolates showing more resistant, more values compared to the port related isolates, where this study is conducted in other study where that compared to this, here it is more. And coming to the sediment characteristics, sediment study, the study region mostly sandy only, covering around 70 to 98% sand, and silt content 1 to 25%, and clay content is 1 to 5% only. Very less clay content is observed. Coming to this, we
studied the different trace metals present in this, and this 2018 studies compared to the 2011. This trace metal concentration increased from the 2011 study to 2018 study. Mostly the chromium, nickel and lead concentrations are higher compared to the 2011 study. The mine overall sediment characteristics of South Visakhapatnam are considerably contaminated with the chromium and nickel, while sediments of seaports are mainly contaminated with the lead. And we also tested trace metals in the different 3 different fish species, where we noticed chromium is little bit higher than the WHO standards, and copper is also little bit higher, and other trace metals are within the standard. Coming to the summary of our study, this dissolved oxygen concentrations are during mainly pre-monsoon season are relatively low compared to the 2011 data, and indicating that increased input of organic matter contamination during recent years mainly, and mean DO concentration in bottom waters mainly in the Tikkabanipalam and Pudimadaka region is little less than the standard DO concentration, that is 5 mg per liter. It's observed 4.8 mg per liter, but other areas it is above 5 mg per liter. And this suggests that seawater qualities in this region are little initial stage of deterioration. And biochemical oxygen demand was also higher during pre-monsoon season mainly. Post-monsoon season it is absolutely okay due to higher currents and usage dilution and other things. And during the post-monsoon, suggesting that possible contamination of organic matter mainly, and relatively higher DO and BOD values during this post-monsoon season, well mixing water is taking place during that particular time. And phytoplankton, as I said, phytoplankton, zooplankton, macro and myobenthos abundance were considerably low at the MOP points compared to the surrounding regions. And that shows this effect is localized mainly. And coming to the other parameters, the major and dominant forms of phytoplankton, and that means diversity of this phytoplankton, zooplankton and other benthic organisms, it is not changed much from 2011 to 2018, suggesting that overall impact on the treated effluent on the release of biodiversity is minimal only. And whole effluent toxicity test treated in the effluent collected from different industries showed that treated effluent is mildly toxic. This is a 2018 study, and we repeated during recent years. Now that is mostly fine. And higher abundance of this total coliforms and indicator bacteria like E. coli and Enterococcus faecalis in the study region than the standard levels is mainly due to the contamination with the untreated domestic sewage. Here, mostly during the sampling, we noticed that mostly it is village related where the sampling part is done, where open defecation practice is common. This might be the main reason, but other than that, industrial water also contributing little bit. And the levels of pathogenic bacteria in the water in the study region is also high. It's alarming, and indicates the significant input of untreated domestic sewage. And on the top, showing higher antibiotic resistance is also of considering alarming condition. And coming to the petroleum hydrocarbons, the higher concentrations in the recent years increased input in these TPHP concentrations, mainly in the north on the coast. But they are within the standard limits. Compared to the 2011 study, it is higher, but they are within the standard levels. That chromium nickel concentrations were higher in the sediment of South Visakhapatnam, whereas lead concentrations are higher in the off Port Visakhapatnam, indicating the contamination of these trace metals from the external sources. And concentration of these other trace metals such as copper, cobalt, cadmium in the sediments of the study region is on par with the standards, and there no significant contamination from the external sources is noticed. And coming to the recommendations, since the dissolved oxygen concentration are depleted and ecosystem at MOP is impacted, continuous yearly monitoring of North Andhra coast is very much required, and monitoring of DO levels and understand expansion and compression of these impacted areas around MOP location is to necessary timely precautions to protect the seawater quality of this healthy of the ecosystem. And recently we are studying the industrial effluent, directly industrial effluent from the all industries, and this shows that monthly study shows that treated effluent is revealed that trace metal concentrations and phenolic compounds are very well within the CPSTP standard. And also the industries improved the quality compared to the 2018 by installation of R1 MBR systems. Results in our monthly studies of bioassay tests showed that some of the industries are mostly compliant with the CPCB standards, but some are sometimes is not compliance. And it is recommended to continue the monthly studies of bioassay to know the clear picture and impact of the biodiversity. Thank you for coming.
Any questions?
Yes, sir. It's a very nice study, sir. Really, it's your study outcome is one of the eye opener with respect to that accumulation of heavy metals in the sediment, and which directly contributing to the fish. It's a really eye opener. So we have to closely monitor these sources. It shows. Lead, nickel, and chromium. Yes, sir. Even though we don't have any standards, but we have to see that accumulation in the fish. So it is exceeding the limit already in fish, that water accumulation. So that is the critical point we have to seriously take, and then we have to endure, sir. Okay.
Sir, how much distance you have taken from disposal point to study area?
2 kilometers, sir.
2
Maximum
kilometers.
2 kilometers. Now, recently we are doing 5 kilometers.
DO levels reduced within 2 kilometers only? Have you done any study
0.5.
after 2 kilometers also?
No, up to 2 kilometers only we study areas, sir. Earlier 2018. Now, recently we started 5 kilometers surrounding area also to know the. Actually, we didn't have the normal conditions where the exactly no discharge concentration. That's why we impacted 5 kilometers radius also. But the effect is nearly 0.5 kilometers, and DO levels are mostly 1 kilometer radius only.
1 kilometer
Yeah,
radius. You have mentioned that hydrocarbons are increased, particularly which area hydrocarbons are increased?
Hydrocarbons, this is mostly throughout the coast, sir.
No.
Mainly this Visakhapatnam, this port region.
Port region. Other areas, hydrocarbons, increase of hydrocarbons may not be chances. Sir.
1 minute. Sir, are you compared the data with the baseline data?
Baseline.
No, you compared with the 2011
study.
to, yes.
Yeah.
Do you have any baseline data of the heavy metals in the sediments? So that is more important. That also we have to look.
Yeah,
Okay.
definitely we have to see. No, sir, only sediments. Sediment only, sir. Fish also we study. 3 species are mentioned.
This in the beginning you mentioned that you have taken out study in 8 zones, no?
Yes, sir.
In this study, have you done the zone-wise analysis of 2011 and 2018?
Yes, sir.
I think that will be more important. Because
But,
then
that-
this, what, this, you have given the overall picture. The same analysis, if you do zone-wise,
Yeah.
we will know the source more
definitely, sir.
accurately. Okay, so,
Actually, that report has given, sir.
no, but for
Yeah,
the
yeah.
zone-wise 2011
Zone-wise,
to 18.
zone-one, it was given,
And
sir.
if we can get that 2011 to 18, the comparison, see, one is you have done pre-monsoon, post-monsoon, that is,
Yeah, yeah.
that is your scientific part of it. But taking the average of 2011 and 2018 is a more historical data. So what I would suggest is that if we can get the zone-wise results of 2011 to 2018 and then come to some conclusion as to what are the areas of concern, I think that will be a better action point for us. Okay, so I think it's already there, then maybe కొంచెం follow up చేసి we can get into the zone-wise.
Predisposed study also you have gada. Any industry before allowing study
Yeah.
conducted by NA only you are allowing because.
Since when is
predisposed-
NIO doing these studies?
What's that?
Since when have you started these studies? NIOS, Vizag, since when it is functioning?
When NIO Vizag is nearly 1974 onwards is functioning, but EAA studies maybe 90s onwards. Exactly, I don't know, sir.
No, because if you can get a historical data,
Yeah,
it will be very
yeah.
helpful.
But recent overall industries data, earlier we are doing industry-wise, single studies, sir. But recent whole industries is 2011 and 2018. All consolidated information is there. But earlier industry-wise, before setting up the plant, we have the data.
The NA was only
Yeah. We are doing
conducting the study kapatti.
Yeah.
Before impact also you have the study. What SAR is studying, you have to compare before 2011, 2018. Then you will know the real impact.
Then we can focus and give the feedback to the industry also.
Yeah, definitely, sir.
Thank you, Srinivas Garu. On the same topic again, effects of marine discharge on coastal environment, but different point of view, from Patra Sivaji Garu from NCCR.
Good afternoon. I'm Sivaji Patra from Ministry of Earth Science. We are from National Center for Coastal Research, which is a part of the ministry. So I'm here with my colleague, Dr. Charan Kumar also. So I'm going to present here that the effect of marine discharge in the coastal environment. So actually, before starting this, I just thanks to Andhra Pradesh Pollution Control Board, because we have a discussion when we have one programs along the Vizag coast. We have a high-level discussion with Nirav sir at Vijayawada, and that high level of meetings will make further our things. Thank you, sir, for that time, your times and recommendation. And second is that our Andhra University Visakhapatnam, because recently we are planning to shift from Chennai to Visakhapatnam. So the Andhra University has given one place to set up our laboratory. At the same time, we are making our own building at Dolphin Nose. And of course, our PIA also is there, because for this Vizag Coast programs, we have given a small funds to our project principal investigator, Dr. Janaki Ram. So he is taking care of our data boy, as mentioned by sir, that morning that we have a data boy, which is at CMFR. You can see that data boy in the CMFR case culture near to that one. So third is our directors and PWQ prediction of water quality team. So our director is very much support and encourage that he always encourages, okay, go and talk with the state government and provide your technical support, because we are sitting in a ministry and doing work, so what state government required, so go and support them. So that's what I am very much thankful. And third is the scientific communities that I have taken for this presentation, that thanks them. So first of all, it's a small that why we required these studies for the coastal environment, because India is having a 7,500 coastal coastline, and at the same time we need to, since it is a developed nation, we need to develop our country. Because why we need develop? Because development required our human needs. When we have human needs, we need to technologically develop. At the same time also, we need to maintain our coast in a sustainably, because coast is giving two. One is sustainable blue economy, we have to maintain that one, and also a socio-economic point of view. At the same time, we need to develop our industries also, because it requires us. So in the 1993, UN has given a small agenda that how we can support life support system, ocean required. And at the same time, the World Statistical Institute also showing that almost 51% of our coast, we are getting, our urban development is going on there. So when a urban development is going on there, of course there is some, our waste material will be there. So in that place, there are so many river points are there. There are so many we need to discharge to ocean in a point manner or non-point manner. However, in a point manner, it is very easy to identify. But what about the non-point? So non-points, we need to go for one classical isotopic studies. So that's what we are also doing on that part. So another also, when you go for the there in the picture, you can see that from land, river, ocean, how our systems will be there. So in between only our urban development, our industries, everything lies there. So why we are, NCCR is much more interested about these studies? Because earlier we have one program called Seawater Quality Monitoring Program. You might have heard that one. So NCCR, Ministry of Earth Science, was doing those programs. We have a 66 location along the coastal, east coast and west coast of India. After that we reduced, and now we are having 42 locations, and still we are monitoring those locations with all the water quality parameters. So that is the difference. So now I'm coming to this point that this is the prediction of water quality program. So when you go for a prediction water quality program, it is a part of our seawater quality monitoring program. So prediction means in the seawater monitoring water quality program, we just monitor. But in the prediction of water quality monitoring, we monitor the water quality and we simulate that one, that for coming 5 days or coming week, how the water quality will be. So in that period, what we know, we have to set up a model. So when you set up a model, we need some point source points. So that's in that process, we have in the east coast of India, you can see that Puducherry, Chennai and Vizag, we have already successfully deployed the data buoys. Now in our next target is Puri and Hooghly in the coming this year. So after that, at the same time in west coast of India also, we are planning to deploy the data buoy. So that after completion of all this our data quality network, we will have a prediction for coming 3 days, 4 days like that. So here you can see that the data buoy, like that there is a RTMS, that is you can see directly, it is open to public, you can see it that every 10 minutes interval what is the water quality, and these are the water quality parameter, basic simple water quality parameter you can see in online itself. So these are the how we deploy the data buoy. So it is more. So this is the thematic diagram coming from 1 to 8, you can see 1 to 7. And when you are deploying all the data buoy, we are always averring to the public that we have a data buoy, and please see whether it is on which level the water quality is for the public information. So this is the most tedious process is like a deployment. So we have done, and we have our Clean Coast app also. So where you can see that one in your mobile phone, that what is where you are sitting when you are in front of RK Beach. So you can see that whether the water quality, what that time it is. So this is the coastal studies along the Vizag coast. Thank you, sir, for you have given the discharge points of the 10 location. Actually, we are confined first in the Vizag coast, but after the discussion with you, we have expanded to your points, and we have started from DE1 to 10 location up to Srikakulam, and these red dots are the things, and you can see the counters 10, 20, 40. We have these counter maps, and we have started this monitoring bi-monthly. So, so these are the points I can say. And here also, when we have the big challenge when we are fixing a model also with this area, because there are so many small rivers are there, and that contains also 2 ports are also there. So along with that, we have started from T1 to T10. We have been started monitoring, and I am going to present those results with that. So what are the parameters we are doing? Basically, at the same time, we are also collected so many isotope samples because to know the non-point sources. So these are the water quality we have started. These are the biological, and all these things we have following strictly APA and GRASSOP, because these two are the standard method for seawater. Because when you analyze a seawater, one parameter will inference to another parameter. So how to manage that one? So these two are the best method for seawater analysis application. So after this, these are the, we have been, these are the parameters we have been monitoring. Apart from that also, so this is the first, I'm telling the pH, okay? And these are the CPCB guidelines for the coastal seawater standards. So these are the having classes is 1, 2, 3, 4, 5. So when we have gone through all this and pH, you see the pH level is 6.5 to 8.5. But here you can see we have taken the reading is up to 8.3. It means it is in the range. And this is for the January 23 and this is March 23. And we have already, in the May, we have started analyzing the data. So since the data is not there, I'm sorry, I'm unable to present here. So you can see that along with, you see 10 meter surface, 10 meter bottom, 20 meter and 40 meters. S is surface, B is bottom. So you can see that, and here you see the number of samples. N is 60 and here N is 54. Here in the month of January, we have collected only 9 locations. But in the month of March, we have collected completely 10 transits. So in this way, you can see the pH in between 2 months is almost within the limit as per the CPCB guidelines. Coming to the point of dissolved oxygen also. So here you see that as per CPCB standards, it should be above 3.5. So let it be 5 also, but you can see our scale. It lies from 4 to 9, 4 to 9. So you can see the red line is the 3.5 milligram per liter, but you see that it is above the line. So it is the environment is very oxygenated water is there. So coming to the BOD, here you see there is a small challenges, but it is not because of the rivers. Because in the monsoon, winter monsoon, this has some BOD values are there, but it requires some decomposition, retention time is called. So that is why most of the BOD values are in the below the line. That is only the BOD value, because BOD is like almost 3 days, 5 days, 3 to 5 days, 3 days, 3 days, 3, yes. So that's because in that time when you decompose, in the microbial cycling is more. So that is the reason you are getting the decomposition, because the monsoon runoff and it mixes all. So Another is, this is the microbiology we have analyzed, but here I request Andhra Pradesh Pollution Control Board to look into this matter, because whenever we are analyzing the microbiology, it's as per the standards, it is MPN, but we all do in CFU for CFU. But that's why I have mentioned that what is the difference between MPN and CFU, I have mentioned there. So that's what I am unable to tell, because they have given all this in MPN. So I cannot tell this is it in the limit or not. But it is, we have in the CFU, we have the standard. We have done it. So
what I will suggest is a very simple thing in this. If you don't have a CPCB norm, it will take its time. Okay, so instead of waiting for all that thing,
Sir.
because you are a scientific body, if you need some assistance of any other scientific body, get associated with it and do a rough translation. Okay,
thank you.
scientific translation as to what is prescribed in MPN, how do you make it into a CFU, approximate. It need not be a CPCB prescribed norm, it could be our internal norm to check the things.
Okay, sir. Thank
Okay.
you. Thanks for your this one. So after this, I have come up with nutrients parameters. So these are the, it's a generally ecological balance, we can say that. That's why we're at red field ratio. So it is from the reference is 1934 onwards, we have been doing whether the system is, which way the system is functioning as a nitrogen limiting or a phosphorus limiting. So when you compare this one, we have seen that all are less than 16. The red line is showing the red field ratio. So it is a nitrate limiting. See, if the nitrogen limiting means the system is the chlorophyll or phytoplankton, all these things, because they required for the nitrogen and phosphorus for their cell metabolism. And that is the most important factor for their food webs. So in that way, it is nitrogen limiting in the sense, but you see that here few patches are there, but it is, we need to see the further investigation why it has come, because since it is only 2 times monitoring and we are yet to receive one more third time monitoring, and also we have the samples for isotopes. So then only I can tell you that why this is, samples has gone beyond that one. So in this way what happens, so we know that the chlorophyll and chlorophyll in terms of phytoplankton, zooplankton, we have done this one. So here we have seen that the high chlorophylls are there because this is a monsoon, so it is there. So then after you see that the chlorophyll is above almost 3. So it is acceptable. At the same time also we have seen the zooplankton also, and the zooplankton also it is regulating that, not only salinity regulating and other factor also it is regulating. So in this way we can say that the community structures and size of the organism can be considered for further conclusion. So we need to have more scientific things so that we can give for the scientific conclusion. So with that, I am just ending by saying thank you.
Just one clarification, very nice, this is sensor-based technology,
Sir,
giving you
sorry sir, it's not sensor, it's a monitoring.
monitoring pulse, okay. So my question was that only. You have put one across the RK beach.
Yes sir.
That, what do you call, buoy?
Data buoy.
With all the thing. And data is collected. Means, what is the process? You are doing sampling or taking the water sample and then doing, or there are some sensors in that which is checking the
Yeah,
thing?
this, just I'm going back to.
Back point. The first one, that is one, and the 10 places that you have proposed, just to have clarity, what are you doing?
Yes, I'll let me explain you.
Yeah.
See sir, here it is called sensors. So in the data buoy itself, in the down of this buoy, one sensor will be there. So these are the sensor, it will be here. It will be moving like this. And before deploying in the water with that, it will be calibrated.
Calibration.
So when it calibrated, it will every time, every 10 minutes interval, the data will come like this.
Okay.
So it is a continuous process, 24 hours continuous process to that particular place.
Boy.
For the boy.
Now, this is the boy process.
Sir.
Tell about the 10 points. What are you doing in those 10 points?
Yeah, these are the 10 points. It's a monitoring points.
Okay.
So we have gone, we used to go by boat.
Okay.
We measure 10 meter, 20 meter, 40 meter surface depth, and these are the 10 location, and these are the locations, you see.
And you are
10,
doing
20, 40.
And you are doing it every 2 months once.
Yeah, by monthly once. And those are these are the parameters we are doing.
We are doing.
So these are the results.
Just as a suggestion for future thing, just go back to the first slide. I'm just thinking as a layman. I'm not a scientific person like you.
Sir.
Suppose I have one spare boy,
Okay.
or some sensors I have spare,
Sir.
and I take the sensor at all these 10 locations
Okay, sir.
by the boat.
Huh.
Take a sample and go to the next location, like that, in
Sir.
every 2 months or every 1 month. Can it be done?
Sir, you can be done. It can be done. But the thing is that you will get only the physico-chemical parameter like temperature.
You will not get the bioparameter.
Bioparameters.
Okay, that is one, but I'm giving you, if you want to reduce your manpower and do this part.
Sir.
So maybe, I want to increase the frequency. That's why I was telling you
Sir.
that if I have a data every month, at least of the if you have one spare sensor, which you take in the boat and do at all the 10 locations, maybe you can do it faster. Now, just for the industries, I want to just say, now this is one of our initiatives, okay? Now, you have seen earlier the NIOS study. We have a historical data of 2011 and 2018, and they are again doing it for this. So this is giving you a data of what is the water quality. Now, this data I wanted to be put on the website and everything for you to see and think. So what I would request you is, like this 10 data what you are giving, please prepare a operational or how to view, how to understand this data.
Okay, sir.
Okay, and we will circulate it to all the industries, especially who are having the marine outfalls, so that you can, from your office, I want self-regulation. I want you to see what is the water quality at your respective point and keep on taking corrective action. And this is not once in 5-year data that we did. This is something which we want to bring in now, that you see for yourself what is the effect on the data. You can question the data. I am not saying that you cannot question. He is there to answer your thing. But this is something which we want to bring in, that marine discharge is taking into this. And please, so this is something of a tool available to APPCB, it is a tool available to CPCB, and it is a tool available to the industry and the citizen at large to see what is the impact. So please take this up very seriously. We are very clear on this, that this should be our goal. And you have made it once in 2 months. My suggestion,
Sir.
if you can bring in sensor technology, even with 90-95% accuracy, and give monthly results on the the chemical technical parts, not the bio parts. I think that will be it. Bio parts you can do it once in 2 months. Okay, so that will be something very good for everybody to continuously, and this data should go to the management straight, that this is the result of your discharge in that area.
In that point.
Okay. Translate into that they will do.
different locations, different points. So it is analyzed through that data is as it shows. But time to time when you collected, it may be the water sample collected from that one for cross-checking.
No, they are going in the boat and collecting some.
Yes, sir.
This is the points are all the physical monitoring samples. Physical monitoring, we go, collect water, and we analyze by ourselves. And give the result. And
That
here,
is why I am suggesting that
and
if they
only-
make it sensor based, that will be.
only one point we have, data is that archive we have this one,
Which
the
is a
data
normal
voice,
data.
it is giving only sensor based. So remainings all, what you have this, all this T10 to T1, all are, we are going by boat.
Just show that data which you are collecting manually, monitoring. Next one, next,
The,
next, next.
no, sir.
No, where did you put those two things, na?
Okay, that is parameters collection.
Parameters. Yeah.
These are.
So this is right now being collected physically by them through the water sample. What I am suggesting is if they can, the Department of Earth Sciences, the first part at least, the left side, if they can make it sensor based, they will also do the work fast. Data will also come up fast. The second part, they can do the physical thing.
Sir, here, sir, some we are using that water quality probe, like temperature, pH. pH
No,
we
those
doing.
are very minor. At
Minor
least you should
sensor.
have to go to
Sir, this-
DO, BOD, COD.
No, sir, BOD, sir, we cannot do it. BOD is, it should be laboratory based.
Laboratory based.
And COD, sir, COD so far we have not done. We are yet, because we have.
So whatever can be done sensor based,
sensor, but
whatever
we are
can
doing.
be done is
So
the.
our is, we need to go to physically to the field, because we need to set up a model for ourselves for coming to meet our, to promise what we have, our nation has done for the promised for SDG 14.
Anyway, NCCR has also setting up an office in Visakhapatnam. He just mentioned we have also allotted them, some land has been allotted in Dolphin. So this is something which they have to do, and this gives us a more, it's not a study based thing, it's a more of a data generation thing for you to access and take. So please, any other question you have? So I just wanted to clarify the, yes, Mr. Naidu.
NIO and NCC are both are collecting data along the Andhra Pradesh coast. Is there any comparison between these two data sets? Any time have you ever compared with these two data sets?
Okay, sir. Let me clarify. NIO has collected the data so many times because we have given one project to NIO for seawater quality monitoring program. Earlier, they have collected the data on behalf of Ministry of Earth Science.
Yeah,
okay, that one. And another also, recently we have given NIO that mesoscoma experiment, because we are sitting in Chennai, so we have our own domain. So we have given that one also to do that one NIO. So now we are doing, if NIO is doing presently, let's have we have no objection or anything. This is, we both are working for the nation, so we have no at all any things.
There should be some comparison whether they will, let us say, DO collected by the NCCR and DO collected by NIO at particular location or at release location, how they are changing. That
comparison. Okay. So if the NIO has done DO value this in month of January, we are ready to do it, or let's have a collect together and do it. We don't have any.
Should be there. That
I think we are ready to do. This one, madam. This data boy, yeah, is fixed one. Yeah, I will show you. Which way it is fixed, I will show you. No, ma'am. No, ma'am. It is, no, ma'am. I will show you. See, here it is there, no? Sensor calibration, preparation of mooring, buoy load using crane, and this is a buoy to deployment. Then we have to lower with a 2 tons sinker because the buoy has to be real time. It's a real time monitor.
What is the depth at that location?
Around 10 meters.
10
around.
meters only. Okay. Is there any protection from fishermen?
Sir. We are talking. We have a discussion with the CMFRI.
Okay.
And in CM, you can see that when you go to the RK beach, you can see some case cultures are there. That is monitored by the CMFRI. Okay. Near to that only we have this data buoy. We have deployed.
Okay. Thank you. Thank you.
Yeah. These are the parameters, madam. Yes, all are.
Yeah. Sir, I just want to ask one question. Whatever studies has been done and whatever results has been found out, what are the pros and cons of it, and what are the policy decision changes has been taken due to those studies? Are it shared with anyone?
Okay, thank you. Your question is very nice and it is very having good depth. So, when Ministry of Earth Science and Ministry of Forest and Climate Change, these two are the two ministry who is dealing with the entire Indian environment, that is irrespective of sea, irrespective of water, irrespective of air pollution, everything they are monitoring. So coming to the ocean part, we are the dealing person for monitoring and giving results to the Ministry of Environment, Forest, Climate Change. And they are the decision makers. It is the clear understanding between two ministries. So we are the monitoring people. We have done all the work, monitoring work. This is the things, this is the where it is there, where it is not there. So the decision part is Ministry of Environment, Forest Change. So in this manner, I cannot give your answer properly, but this is the thing. So our territory is to monitoring, giving the reports to this. And in terms of our data, we can publish scientifically and we can say these are the things, these are the pros and cons, all this. Thank you.
No, anyway, we had the sea water quality standards prescribed by the CPCB, if you have seen, and our job is to ensure that the sea water quality meets those standards. That's the job, and this is the thing. What we had till now, let's put it that way, we had around the marine discharges. You heard CPCB speak earlier discharges were allowed. Now that discharges thing has been removed by marine discharge and with a particular standard, with a pipe and everything, at location and diffusion standards and everything. Till now, we were saying we will monitor the quality of water, what is going into the sea, and we brought in the concept of a guard pond, we brought in a concept of a measurement, and the only way to measure the water quality was ask the NIOS or ask sciences, and all the pollution control boards have been doing that studies of the sea quality and monitoring and saying that whether things are okay or not okay. If you have seen the things like when they gave the APPCB gave the presentation on sometimes the effluent water was not meeting the standards, they were asked to recycle and reprocess the thing and then send it. So one part of the thing is, before letting off the water itself, you check whether the discharge water is up to the standard. That is the pollution control board which works on that. Now these two presentations which I requested them to make was specially on the ground of, till now we were periodic study based. After 5 years we are seeing that what is the water quality. So 2011 it was done, 2018 it was done, now they are doing in 23. But that is too late for an action or a corrective action. And that is why I had a discussion with Secretary Earth Sciences and I requested them, I need, if not real time, at least as data quickly as possible. So suppose marine discharge, let's assume that the marine discharge is meeting all the standards of our CPCB prescribed norm. And still the sea water is getting affected by something, at least we get an alert quickly that we want to take some action. If the marine discharge, if our first assumption is that if the marine quality is bad, there is some cause for that and the industry will be the first point we will check it up. So that is the whole purpose, and that's why, Mr. Patra, I request you, this data has to be online and you must have a user manual how to use this data. so that we will circulate it to all the industries. Navy can use it. You will get a water quality. These are, and I have been little, I would say in my discussion, I have been little focused on the discharge points because my presumption is that these points will be the most affected or most polluted, if you can put it that way, isn't it? So that's why I have requested them these 10 points, and they have taken it up. I thank please convey my thanks to the secretary. He has been very nice, and they are doing it mostly out of concern for the thing. And madam, I will tell you, let Kadalur come and learn from us what all we have done. They are far, far behind us right now. So we have done much more, and see what thing, and please put this system properly. Sridhar, I think you should take a lead and get this system. I think we are checking the water before it is discharged. We are checking the sea every month. I think this is the way to go. That is the thing. So please see that this is computerized, web enabled. Your data should be on time. If you are said on every 2 months, let it be on time and you should say date of declaration of results.
Thank you,
and
sir.
Put it there, and every day it should be on that thing. Okay? I think I've answered your thing, yeah?
Sir, thank you, because of last 2 months, we are like with our own work, so that's why I'm unable to what we have done, because so that's what the things is getting delay. So we are. No, it is, we have gone, and it is now in the competent authorities just to show that, and it will come back so that we will have established that.
Something which we really will be a far-reaching thing for all over the country,
Yes, sir. Yes, sir. We have our Ramnamurthy sir and our secretary is in the list. So hopefully within a month we are going to make those things, sir.
And
Please.
take that suggestion. If you can make it sensor-based and every month result, it will be extremely good. If you can spare one set of sensor for all the 10 locations.
Okay, sir. Thank you. Thank you, sir.
Thank you very much, Patra Sivaji Garu. The major outcome, we saw that generating a data from the NCCR, and that will be available online monthly basis. And the outfalls, impact of outfalls can be seen on monthly basis. We will be, all the stakeholders can understand what is happening. Then the next topic is desalination plant, issues related to desalination discharges and marine discharge standards. Mr. Sai Bhaskar Garu, please come on to this.
Good afternoon, delegates. I am Bhaskar. I'm an environmental engineer, and I did my master's from IIT Kanpur. I'm working with a company called Cholamandalam MS Services. First of all, I'd like to thank Pollution Control Board and Government of Andhra Pradesh for giving us this opportunity. So, yeah, this is fine. Yeah, thank you. So, right. Today, I would like to just take probably another 15-20 minutes, not much of the time, try to look at from a designer angle as a project proponent angle, how probably which we can definitely look in some of those aspects which I would like to discuss on desalination plant area. So when I'm saying the desalination plant, the definition of the desalination plant, all of us, we try to look at it, still obscure. It's not been very well defined into it, whether even the raw water. Let us today, if you see, any industry, if you go back now today, the raw water, groundwater is being used, and groundwater sometimes it's been treated and being looked at. That is also called as a desalination. Even if I'm taking a small water even from the, the river, or if I'm talking about even from the sea that has been processed to the membrane system or any other system, still that is also been called as a desalination. That means the desalination means I'm trying to remove some of the salts. And there is a third dimension today. All of us, I think you know very well, today the sewage is also becoming an input. So the sewage is being treated and being reused. That also has got certain enrichment of the salts because sewage has been treated in the MBR, MBBR, all the technologies. And then subsequently it has been passed to the RO. Once it has been passed to the RO, it is getting the TDS, that means the concentration is getting enriched. So The definition of desalination plant need to be clearly defined. That is the first thing which we would like to look at. Then subsequently, we have to look at, unlike the CETPs or even other industrial effluents, the desalination plant for us, the only concern which is being there on the TDS. And there used to be some concern, especially on the heavy metals, which I'm going to discuss quickly in another 2-3 minutes. So we need to deal with how we are going to address the TDS. Because TDS is the only issue, what are the other alternatives? Should we have to apply the same rules what we have for the CETP, or we need to definitely look in something else for the desalination plant? Because desalination plants can start even with the 3,000 meter cube today, even up to 1 million meter, what we call 1,000 to 15,000, 20,000 meter cube, that kind of the wide range that is really happening into that. So let us try to look at. So here, apart from the general activities, we need to consider even economic scenario, that is number one. I would like to say techno-economical aspect, we need to look at it. Then definitely the ecological aspect is very, very important, which we need to have. And over and above, we have the same thing, which is very important, is the social dimension. So today I would like to address all these three. Let us try to see how we can really come up with any specific guidelines for this kind of a thing. I'll just to quickly look at. So as I just mentioned, the desalination plant technology is altogether, it all started in the Middle East. If you try to look at where you have the thermal based system. You used to use the steam, and the steam has been converted. Now, based on the steam, you're going to convert that into the fresh water for the high quality water. This is the distilled water. Now we have on the land-based system, everywhere we have the RO technologies for the last 20 years, which is being there. RO systems have been advanced now today. The energy, the intensity has been reduced. It is more economically viable. I still remember when we started installing somewhere in 1999 and 2000, my RO operating cost, it used to be around 70 to 80 rupees. But today, definitely because of the energy conservation, I'm able to do it at 30 to 40 rupees. So thanks to that kind of the technology, energy recovery, that is what is happening into that. But now, all my colleagues, other earlier predecessors already told about, we have now the new dimension called net zero. That is called the decarbonization. You want to become, climate action. That is very, very important under the SDG goal 13 we have into that. So there are certain hybrid technologies will be coming up. What is hybrid technology? I want high quality of water. At the same time, I don't want to spend too much of the fuel or the energy, everything. That is what we call is the hybrid system that is going to come up. So by 2025, 2030, this will be the new area. So considering all of these aspects, we need to define very clearly how for each of these technologies, what will be the discharge characteristics. That's what we need to look at. One good advantage which we can see in this, whether it is a thermal, whether it is a mechanical, today for the desalination plants, the temperature is not an issue. So thermal pollution is not a problem at all for me. It is only the TDS which I need to definitely look at it. Now let's try to look at the next areas. Whenever I'm seeing an RO plant, definitely there are certain blue color which are highlighted. These treatment units, individual units, you are going to get some amount of the pollutants. That means from the primary clarifier, when you have the settling, definitely there will be some amount of pollution that will be coming up. Then subsequently, I'm going to use a lot of chemicals, especially for the CIP, that is called the cleaning in place, conditioning and everything. So there should be some kind of a change, even kind of the chemicals which we are going to use it for the conditioning and the CIP. This is also one requirement which we need to look at. Now, let's try to look at as a complete cycle. No matter if I am saying as a desalination plant, whether you call RO, seawater RO, the different names which we are trying to give that. But ultimately, you have the pre-treatment, you have the actual RO, would like to say the UF and RO system, then finally, I have the rejects system. For each of these areas, which I am trying to highlight some few points, we require some basic guidelines. That is something is very important. As I just mentioned, the desalination process itself is going to change by 2028 and 2030. Let's try to look at quickly into that. So the pre-treatment, when I'm saying the pre-treatment, there should be some minimum guidelines that definitely will be required, depending upon the size. So when I'm saying is a 3,000 meter cube plant can be compared with a 25,000 meter cube plant, you cannot. Because 3,000 meter cube is a small plant, I cannot discharge everything into the sea, which can be taken, say, 2 kilometers, 3 kilometers. Can we do that? Economically is not possible. But can we avoid that 1,500 meter cube or 1,000 meter cube, 3,000 meter cube RO plants? Still we cannot avoid because that's a process requirement. So let's try to look at what we have to do Whether the size is very important, what is the threshold? We need to look at into that. So for the intake process, we need to have at least, I've mentioned here 5 different elements probably we need to consider. Both the industry, definitely when you are trying to design, considering your ecological aspect, that is number 1. Oil and grease is a very, very important parameter. So whatever the data now, the huge data that is getting generated, that will be definitely helpful, because each of these elements are going to impact my RO plant. If my raw water quality is an issue, if the TSS is an issue, if the oil and grease is a big issue, I think all of you know very well there is one marine oil spill it happened in the southern part of India that has really affected many RO plants into it. So that's going to have a bigger issue for handling, how I really treat that and put them. So that is also another area which I need to look at. If there are more phosphates which is being there, you need to go with a robust pre-treatment system. That's going to generate a lot of chemicals and the waste, TDS is increasing. So there should be some minimum guideline even for the RO itself. Now come to the rejects, which is very, very important, which I thought I would like to just bring in some kind of perspective on how the other parts of the world they are trying to look at. Because as I just mentioned, unlike CETPs or the industrial effluents, you don't have the COD and BOD. That is something is good. Only, as I just mentioned, TDS and few amount of chemicals. That is organophosphates has been most commonly used in the RO plants. Now slowly it is getting phased out into that. So phosphate is one important parameter. We need to keep monitoring very closely into that, because any phosphates that is getting into the marine, it will have definitely an issue into it. So now let us try to look at how it will be there. So already I think the discharge standards have been already mentioned, but I just highlighted some of them in the light pink color, which you can definitely see. These are all the areas which we need to definitely closely monitor when it comes to SWRO, seawater RO. But our suggestion, which we would like to look at, it is only just a proposal. Definitely we need to have some limit even for the discharge. TDS, very, very important. I'm just saying here we have done more than 50 plus different studies, especially the marine outfall models and everything into it. So at least we need to keep it a minimum outlet to discharge. It should not exceed 60 ppt. Why? I would like to just give in the subsequent slides. But rest everything is all fine. And especially the phosphates I just mentioned, we need to focus more on the phosphates when it comes to. And then another thing is there are certain chemicals which we use that is a chromium based. That has been already phased out, so we need to have some policy that will be there as a non-chromium based, the CAP chemicals that can be definitely looked in. This is what which we can see that. Then next thing which comes up here is across the world, there is called parameter called the dilution factor. So that's what was already we discussed in that. We have the CPCB guideline for the CETPs with 150 dilutions, which we are talking about it. But I would like to just clarify here. The dilution is not based on the concentration. Dilution factor is based on the density. That means an effluent, an RO effluent which is at 60 ppt, the density will be almost around 20 to 30% higher than the background water. So you need to get a dilution based on the density difference of almost around 150 to 50. Then you will get a better dispersion. Of course, concentration is always important. But unlike other, pollutant, if you take about, let us say the BOD. BOD is a complex, parameter. It is not a parameter at all. It is an organic matter. It is getting degraded. So the dilution rate, it is a complex scenario. But at least for the salt, whatever the sodium chloride I am talking about, what is this, calcium sulfate, which is being already there, it is a simple physicochemical phenomena where you have the background concentration of 37 ppt, where I am discharging at 60 ppt. So definitely there is a chemical, diffusion that is going to happen in addition to the advection from the current that is going to look into that. So let us look at in this simple model. So when we have done I have done around more than 20 plus different modeling studies, especially for desalination plant for various kind of sizes. At the source, immediately you will be able to get 30 dilutions. Just you dump it, you will get 30 dilutions. That means if it is a 60, you are going to get almost as a background plus or minus 3 to 5 PPTs. That's what I would like to say. But the real issue, from this 3 to 5 PPT, you need to bring it back to the background level. That's the real challenge. It's going to take time. That depends on so many other factors. That's where we require some amount of other areas. And also I would like to just say, in the slide, if you try to look at, that's what we can say, the MOF and of course CETP outfall, we are talking about 150 dilution factors. I feel sometimes it's challenging, but of course the distance of 100 meters, which we are talking about it. But at the source, please kindly, I think we should include one more parameter as a part of our standard. Why don't we include dilution factor at the source as a 30? So the designs will be very, very feasible, and then you can come up with more practical and pragmatic aspects into that. Let us quickly go into that. And as a part of our environmental impact assessment studies, the design, everything, we do lots of complex model studies will be there into it. But all of this, what we call the models, setting up the standard, setting up the model, calibrating the model, it's all resource intensive, correct? If you want to discharge, let us say 5,000 meter cube RO plant reject. Going through the entire process is definitely a cumbersome, it's resource intensive, and we need to take some decision into that. So that's the reason what I would like to say is, just like your minimum stack height formula, what we have, I think the few days back you have seen, now based on not just S42, now you have even for the PM also now included for the minimum stack height. Like that, if you can come up with a minimum empirical formula, there could be some error, 20%, 15%, that's all fine, but immediately we can see whether that particular outfall with that concentration, with that quantity, what will be the tentative impact. This is what we would like to say, the regulatory screening process, this has been very well applied in Australia. So this kind of the methods which we can say is a screening level. Then we can go into a detailed manner later. Then again, the other parts of the world, as a part of the screening, they would like to see if you want to discharge, if it is a small plant, if it is say 5,000, 10,000 meter cube desalination plant, so definitely it can be allowed into certain estuarine environment also. Of course, not in the open areas, because most of the coast in the areas, open coast, it has been, tourism rich. So definitely we cannot take that kind of a risk into that because it's economic loss, but definitely within the sea. So what is most important here is, depending upon the size, that means let us limit the size. If it is, let's say, around 25,000 KLD per day of the desalination plant, what will be the possibility whether we can discharge into the nearby creeks? Because it's a small size, because laying the pipeline, coming back to, looking into the other aspects into it, right off the way, there are so many issues. But this has been very well done in other parts of the world. Now let's look at the last one. Is, I think already my colleagues, which has been already talked about, the marine impact. What I would like to just say is, you have the three types of species, all of us we know that. Once you have the freshwater species, you have the estuarine species, which can withstand for both osmotic pressure little bit from the marine and also from the freshwater, that is the range. Then you have the seawater species. So what's more important we need to look at here is, what is the tolerance of these species for the change in osmotic pressure, that is the salt, which we can definitely look at, the zooplankton, everything. Most of the studies have said even up to 5 to 6 ppt, they can withstand, there's no problem. And as far as, if you see the benthic has got higher tolerance. That can take even up to around 10 to 15 ppt. Of course, it's case to case, we need to look into it. So the dilution factor of 30 to 50 at the source, I feel it's reasonable and it can be immediately achievable. And for the smaller plants, also we can definitely look in how we can do that. So let's look at this small chart. What I thought was, it may be handy for a screening of a project, whether that particular project can be permitted in that particular location, depending upon the ecological status. We're all monitoring the data, but how we can definitely use that. This is how, other parts of the world, they try to look at. There are 4 quadrants. That's what we have to look at it. If you see, I would like to just talk about the quadrant 1, 1, 1. Wherever there is a 1 is there, that is rich in biodiversity. What is meant by rich in biodiversity? The number of species, you can see on the x-axis, and you can see the density of the species. That means there is more number of species, even the density is also very high. That's what we are talking about on the 1, 1, 1 boxes. So these are all the areas definitely you need to consider. You need to have some buffer zone, at least 500 meters away. That means no outfall should be located within 500. I'm just giving, it's not 500 meters, I'm just trying to postulate. That kind of the minimum distance can be put in for boxes 1 and once you do the monitoring and everything into it. Then you have the boxes 2. The boxes 2 is very well you can permit, but with a minimum dilution factor. you can decide 30, 40, whatever, because I'm just taking the European Union, they have taken 30, where you have the minimum biodiversity. Biodiversity is being measured with a unit, what is that called? Shannon index. So once you have the Shannon index for that particular area, that means the number of species, the evenness, and the density, then definitely we can decide where, all those two areas which we can definitely look at. But there are anomalies which we can see here. There are red quadrants. You can see the 4, 4, what is happening on the top. These are all the 2 4s you are seeing here. This means definitely there is some interference of the pollution. What is happening? Density is very high, but number of species are less. That means only pollution tolerant species only is able to survive. If you are going with only the density, I am definitely misled. I am more interested not on the density, I am more interested in the number of species. If you are introducing more new pollutants into the environment, if you are adding more salt into it, definitely the number of species, the diversity of the species will be lost. That is where we have to protect. The laws will be more stringent on the number of species, not on the density of the particular one. So whenever you have the 4 quadrant, let's do a deep dive. Those who are doing as a part of the EAS studies, environmental impact assessment studies, they can do on the 4. But something is very peculiar. You see on the last, that is, we have the last quadrant at the bottom, that is called the number of species are more, but the density is not there. This is something is very peculiar. This is very specific to that particular ecology. You cannot disturb that ecology. The bottom 4, whatever the quadrant is there, we cannot discharge anything in that particular area. Once it is being there, it has been lost. Normally, which I have seen, whenever you have coral reefs, you have, sea grasses, that's where you are going to get that. So that need to be looked in. So this quadrant can be utilized for the screening purpose. So of course, monitoring programs, already we discussed into that. Yeah, I would like to just summarize here. What we would like to just present overall is seawater RO, as I just mentioned, we need to define what is as a desalination plant, what is the maximum capacity, what is the minimum capacity, where it can be discharged into the outside. That is the first thing which I would like to say that. Then environmental friendly chemicals, then try to avoid all the heavy metals, especially for the CIPs, that is one thing. As far as possible, organophosphates, which you are using for the CIPs, that also you try to avoid, so that eutrophication in the downstream will not happen into that. Then we should have some limit for the discharge. I feel 60 is also okay if you are getting 30 as a dilution factor. That also we can try to look at. Of course, 150 is always good at 100, but I would like to say 30 at the source. That's where we can definitely look into that. And then concentration should reach to 1500 meters as the background level. Otherwise, what is happening today? We are not able to say what is the real impact. 600 meters impact, 500 meters, no. CPCB has already clearly mentioned, it should have 1500 meters, at least you reach it. So let's keep this as a guideline so that we have clarity on when we are trying to look at. And I'm just mentioning 500 meters away from high biodiversity zones. What are the high diversity? 111. There are the boxes, 4 boxes. Let's have that into that. And then ecological monitoring always we are doing into that. Yes. Thank you so much for this opportunity. If you have any thoughts, I would like to take.
Any questions?
Yeah. Yes, madam.
100 meters away from the discharge point, it should be the 1500 times. Okay, this is our
Exactly. That's what.
okay.
Correct.
Then whatever your suggestions, we cannot take it to it. Depending on the SNO study.
Yeah. Yeah.
Okay, and concerned department has to study, and then they have to
Yes.
suggest.
Yeah, actually this, the present position is little difficult in the desal plant because we don't have a prescribed norm other than a marine discharge.
Yes, sir.
So we don't have a desal standards. I think now that the industries are coming up very fast with the proposals of desal plant, I think they need to also push the Government of India, Ministry of Environment and all to set up the standards as soon as possible. But this subject was specially included for Andhra Pradesh that now we are getting proposals for desal plant, and at least we need to work out our internal processes very clearly with the thing, duly complying with the marine discharge standards as it applies today. Okay. So that is what we are working. You have suggested something. We'll have to just, means whatever are your suggestions, are they as in accordance with the just last slide, but are they in accordance with the marine discharge standards, or it is a relaxation, or it is what?
Yes, sir. Actually, there are two probably areas which we are trying to look at, sir. Yeah. What I'm saying is, at the point of discharge, we can say 30 dilutions may be feasible. What I'm saying is in real, but of course 150 at 100 meters.
150 is now standard.
Yes, sir. But 150 at the source, what really happens is, let us assume, madam,
Your right now is 150 meter at a source.
And one more thing, Government of India is encouraging utilization of sewage, because almost all our coastal region,
yes,
this one, sir, many yeah, I think so class B cities,
yes,
no, not class B, even class A cities are located. So enough sewage is there, so treated sewage. So we are encouraging to utilize treated sewage
but
for
madam,
industrial purpose.
By using sewage,
yes,
madam, what I am doing is, because I am passing through RO, the sewage TDS of 500 is becoming 5,000. Because it has to be passed through the membrane. I need to get the better quality water. So it's not based on, what I'd like to say is, this is done based on the sewage, because sewage has got the BOD. But desalination plant, I don't have BOD, it is a TDS. TDS can be mixed very rapidly because it's a chemical mix. That's our submission. Across the world, in Europe, it is only 30.
No, the problem here is we don't have the desal plant next to the sewage discharge, so we'll have to think about it. Okay, any question? Otherwise, we'll move to the last presentation. Yeah.
Thank you very much, Bhaskar Garu. The matrix density versus spaces gives an idea about how to discharge and where to discharge.
We have to use for calculation of dilutions? Which model we have to use for calculation of dilutions at 100-meter distance? Because we use two types of models. One is near field, second one is far field. So near field, 20, 30 times dilution we get it. That is with 6-port diffuser or 7-port diffuser, we get near ambient salinity at that point to itself. But 100-meter distance, 150 times dilution means little bit problem for any industry.
On the threshold, sir, we like to see what our experience is. Up
Okay.
to 25,000 CLT discharge in HE. As the volume increases, what we found is anything beyond 25,000 meter cube, that means you're going with a 50,000, 100,000, then definitely the dilution rate will come down. So, because
is okay.
the size we have to look at it.
The total quantity of the effluent is important, quantity of the brine.
Because any
That
industry today, what my experience we can say, the industry today, maximum you are getting 25,000 meter cube something.
Because high density effluent, it reaches to certain distance
No,
and comes.
what I would suggest is we can have more discussions on this,
okay,
because still, the subject is wide open. Right now, no decisions have been taken. So, but anyway, it was more of a, presentation on the desal thinkings for all of you to think about and accordingly come up with the things. Yeah, next.
The next topic is issues on CRZ, Visakhapatnam marine discharges, by Dr. Manik Mahapatra, scientist, NCSCM, Chennai.
Good afternoon all. We are in a transition period, because we all know that the CRZ notification 2019 supersede CRZ notification 2011. In para 6.1 of CRZ notification 2019, which stated that the state need to update their respective CZMP, And until unless the CZMP is so revised, the provision of the CRZ notification 2019 will not apply. So at this time, that's why we are telling we are in preparation stage in the CZMP as per 2019. And before going to the jump to the topic, the issues on CRZ, I just made this presentation about the basic about what is next slide. What is this is not. What is CRZ, then what is CRZ map, and then next is what is coastal zone management plan. Then the major difference between CRZ notification 2019 and CRZ notification 2011. Then I'll quickly go through the CZMP preparation steps. Then lastly, I'll discuss about what are the provision mentioned in CRZ notification 2019 regarding the marine discharge. As per the provision of CRZ notification 2019, the coastal stretches of the country and the water area up to its territorial water limits, excluding the islands of Andaman and Nicobar and Lakshadweep, and the marine area surrounding these islands as coastal regulation zone. And the jurisdiction of coastal regulation zone, as is mentioned, in case of seafront, from high tide line to 500 meter. In case of tidal influence water bodies, then 50 meter or width of the creek, whichever is less along the tidal influence water bodies. Then high tide to low tide line, that is called intertidal zone, and low tide line to 12 nautical miles on the seaward side, and then low tide line to opposite side of the low tide lines along the tidal influence water bodies. This is our CRZ. The next. What is CRZ map? Because when CRZ clearance is required, there are among other requirements, one of the important requirement is CRZ map. So CRZ map, basically a map in 1:4000 scale depicting the high tide line, low tide lines, and the CRZ categories of the project site in as per the approved CZMP database. And that map need to prepare by the authorized agency approved by the ministry, and the project layout superimposed on that map and depicting the project boundary and existing project activities if there, or proposed project activities. So this is clearly defined. And among others, there is another map need to be prepared, that is called CRZ map covering 7 kilometer radius. That map has to be 1:25,000 scale and depicting HTL, LTL, all are the CRZ categories. These are the 7 authorized agencies listed here who can prepare the CRZ map and CZMP. Next is, what is coastal zone management plan? The CZMP basically is a map on 1:25,000 scale depicting high tide line, low tide line, CRZ categories, administrative boundaries, and other benchmark details. And this need to be prepared as per the annexure 4 to this notification, which involve public consultations. So who can prepare the CZMP? Basically, the state need to prepare the CZMP by engaging one of the agencies approved by the ministry. The importance of the CZMP is that all development activities listed in this notification shall be regulated by the state or union territory, local authority, or concerned coastal zone management authority within the framework of such approved CZMP. And while clearance of the CRZ map, the authorities should review the documents as per the approved CZMP. So apart from that, because CZMP, as I said, it is a map, but there are, along with the CZMP map, the state need to prepare some management plan. There are important management plan, are shoreline management plan for the eroding area, environment management plan for ecologically sensitive areas, IMP, that is integrated management plan for the critically vulnerable coastal areas, and IIMP, Integrated Island Management Plan for the islands, and Tourism Management Plan and Fisheries Management Plan. So what are the difference between CRZ? In case of CRZ jurisdiction, as per CRZ notification 2019, it is edgetail to 50 meter or width of the creek, whichever is less on the seaward, landward side along the tidal influence water bodies. Whereas in 2011, it was in 100 meter or width of the creek, whichever is less on the landward side along the tidal influence water bodies. Second is, as per CRZ notification 2019, it's cover all backwater islands and islands along the mainland coast. Whereas it's in 2011 notification, it's cover only the backwater island of the Kerala. Number 3. In CRZ notification 2019, for the island, there is a 20 meter CRZ area, subject to prepare the integrated island management plan. Whereas in 2011, the CRZ area was 50 meter only in the backwater island of Kerala, and for the offshore island, it was in 500 meter. Now CRZ classification, CRZ 1A. In CRZ notification 2019, where the mangroves which grown in the private lands and the patch area more than 1000 square meter, there will be not required a buffer of 50 meter. Whereas this 50 meter buffer in the private area as per CRZ notification 2011, it is not there. This provision was not there. The next, the details environment management plan shall be formulated by the state and union territories for the CRZ 1A area, basically ecological sensitive areas. However, this provision was not there in 2011. Now recently ministries added the eco-sensitive zone around the protected area, they consider as a CRZ 1A, which is included in CRZ notification 2019. This provision was also not there in 2011. Next, this is CRZ classification in CRZ 3. Basically, we are talking about the undeveloped area. So in case of CRZ notification 2019, based on the population density, the CRZ 3 area has been divided by in two, CRZ 3A and 3B, based on the population density 2161 per square kilometer. If the population density greater than 2161 per square kilometer, we are calling CRZ 3A, and their NDZ is 50 meter. Whereas if the population density is less than 2161, their NDZ is 200 meter. But such kind of density-wise classification, that provision is not there in CRZ notification 2011. This is the pictorial representation about the CRZ, difference in CRZ jurisdictions and the classification which I described earlier. So now these are the major difference about the prohibited and permitted activities in CRZ 1 area. Ecotourism activities such as mangroves walk, tea huts, nature trails, etc. in CRZ 1 area are permitted activities, whereas in 2011 it was prohibited activities. Existing fish processing unit may be utilized 25% additional plenty area for modernization purpose in CRZ 1B areas are permitted activities, whereas these are prohibited activities in 2011. Certain salt marshes which have less biodiversity and identified by NCSM and demarcated in coastal zone management plan can be considered for salt pan activities. In CRZ notification 2011, does not make a distinction between salt marsh based on their diversity they support, no mention of their conversion to salt pan. Another prohibited permitted activities in CRZ 2 area. In CRZ, as per CRZ notification 2019, applies town and country planning norms as changes from time to time and according to FSI and FAR as on the date of this notification for construction or and reconstruction of building in CRZ2 area. Basically, the FSI and FAR is fixed based on the date of notification, whereas in 2011, that it has to be level of 1991 level. This is prohibited activities in CRZ3 NDZ area. Construction or reconstruction of dwelling units of traditional coastal communities, including fisher flock, incorporating necessary disaster management provision and proper sanitation arrangement is permitted in NDZ, whereas these activities is permitted only 100 to 200 meters from HTL along the seafront. Number 6, temporary tourism facilities in the beaches such as shacks, toilets, washroom, change room, shower panel, walkway, these are is only are permitted area are permitted, whereas these are its provision is not there in 2011. Wherever there is a national or state highway passing through NDZ of CRZ 3 areas, temporary tourism facilities such as toilets, change room, drinking water facilities and temporary shacks can be taken up on the seaward side of the road. And on the landward side of such road in the NDZ, resort or hotel and associated tourism facilities shall be permitted subject to prepare the tourism plan. But this provision also not mentioned in 2011. And disposal of plastic into the ocean water is prohibited activities, whereas this provision also not mentioned in 2011. So now these are the delegation. I think it is well known. I am not covering this. Now this is the how CZMP can be prepared. I know I am quickly go through it. Just now this is relevant to the issues related to CRZ. As you know that no new industry and expansion of the new industry is permitted in the CRZ area. So now what are the provisions mentioned as per CRZ notification 2019 regarding the marine discharge? In para 4 of the notification, which stated that the discharge of untreated waste and effluents from industries, cities or town and other human settlements are generally prohibited activities in CRZ. In para 5, regulation of permissible activities in CRZ 1B and CRZ 4. Activities shall be regulated or permitted under foreshore requiring facilities for transport of raw materials, facilities for intake and cooling water, intake water for desalination plant, etc., and outfall for discharge of treated wastewater or cooling water from thermal power plant in conformity with the environmental standard notified by the Ministry of Environment Forest and the relevant direction of CPCB and the State Pollution Control Board, as the case may be. Regarding the regulation of permissible activities in CRZ 2 area, it shall be responsibility of the concerned town planning authority to ensure that the solid waste are handled as per the respective solid waste management rules and no untreated sewage is discharged onto the coast or coastal water. In Annexure 3 of the CRZ notification 2019, in the guidelines for development of beach resort, hotels and tourism development project in the designated CRZ areas, that is CRZ 2 and CRZ 3 areas, where it is stated that the necessary arrangement for the treatment of effluent and solid waste must be made, and it must be ensured that the untreated effluent and solid waste are not discharged into the water and on the beaches, and no effluent or solid waste shall be discharged on the beaches. Thank you, sir.
Any quick questions? Okay. Now we came to the end of the technical session. Thank you all. I request our Special Chief Secretary to make a concluding remarks.
Before I make any concluding remark, anybody has any issue with any of the sessions which were held here, because we have come to the end of the workshop. So anybody has any issue or any question or anything still lingering in his mind as to what is to be done, then okay. If not, then I just would say that, as you have seen, we had a wide array of subjects today. We told you the existing marine discharge standards and the APPCB norms. We told about the new technologies in the ZLD, segregation of the effluent and giving a better. We told you the monitoring system which we are thinking and contemplating, apart from the SOP which is on dealing with the on-land discharge of water, what we are doing on the earth sizes, on the ocean for monitoring the things. And we also gave you some feedback on the regulatory mechanisms and also on the new thing which is coming up in a very big way. Many of you are applying for the desalination plants, and we don't have a specific standard for desalination plant. We have a general standard for the desalination, that is the marine discharge standard. So we have covered a wide array of subjects. Our essential aim after this is to go for what I call the marine discharge 2, the SOP 2, for as far as the APPCB is concerned. So I thank you all for participating. I thank you all for coming, taking out time, and your inputs are valuable. So even if you feel like giving some input in writing, please send it to the APPCB. We will be very happy to consider all these things, and you can send it by mail to the APPCB. We'll consider that. And I thank you all for coming, and anyway, if you want anything more to be discussed, we will all go for the lunch and we will discuss it there. Thank you very much.